Hello, good evening and welcome to everyone. I see you've got a nice bunch of people already in here, as usual, as expected, and as I hoped. A few shout outs: Harry Warp, Aniceto Maldonado. I was going to struggle over that, I'm sorry. Dr. Osiris, Gary Isle of White, hello to you. Crafty Keeler, I saw. 9 o'clock Hero, good evening to you. Lots more: Fred Bailey, Tusk, Steve I. What's the I stand for? I don't know. Who else we got? Clive Wells. I'm not sure if I mentioned you. Dr. Osiris. I see talk about... Now Pinion. Good evening now. Glad to see you there. Hope Little Miss Now's okay as well. I did notice... Heat Shield, yes. And Jessica Mills. Demon Orb and plenty of others. I'm sorry if I haven't shouted you out. You know that I appreciate each and every one of you. And I did see comments about which is more likely, a Mage flight or Mr. S with no sound. Let me just check that for 1 second. Yeah, I had sound. Booyah! Well, I hope you all enjoyed my quantum eraser video a few days ago. I certainly did. And it certainly looks like it went well, because the views were more than double my normal. Absolutely phenomenal. I should have done him before. I've always avoided QE because his videos are so darn boring. Maybe I should just do a script, write an auto script to respond to his script, and he could do one back, and we could both go down the pub and leave them going. I don't know. But it's gone well. Right, I have seen, as I said, people mention about Mage. Well, I hope you've all been watching my community tab. You have been watching my community tab, haven't you? You have. Because Mage is dark. I think it was Sunday, I posted a message saying Mage is dark. We're in the launch window days, and you will hear nothing, and I will discuss nothing until I make an announcement. Sorry about that, people. You're just going to have to wait and see. So make sure you're subscribed. Make sure you've got notify all set. Which reminds me, I did get a message from someone who said that they're failing to get notifications. As you may be aware, I hope you're aware, YouTube has had some fun and games with that sort of thing. And it appears that the resolution is to unsubscribe, subscribe again, click notifications, and then select notifications all. It doesn't seem to have affected my channel as much as it's affected other channels, but I know that some people haven't been getting notifications or weren't. So that could be the resolution for it. So it's worth a try anyway. So I hope you're all having a good week. I've got a hell of a lot on in my life. I'm not going to go into that too much. But a couple of times I've had discussions on here about all this, the cigarettes. And I said that I got something major going on, and once that's sorted, then I'll look to sort that. We are now that close to it. I've been given a date. I don't know if it's a definite date, but I've been given a date of 1st of September, and shortly after that, everything should, I hope, I pray, be rectified. And my life will get 10 times easier. So I'm really, really looking forward to that. Got a couple of things. We may have a guest, pre-arranged guest or two. There were several people. One has had extremely short notice. We discussed him coming on. He had come on that night when we had all the buffering issues. That's Johnny Orbital. He with a fantastic name. But we weren't able to bring him on because basically YouTube was screwed. And we're going to arrange for him to come back on. I had discussed about him coming on tonight, but it was still up in the air because I didn't know what I was going to be doing tonight in the end. But as it turns out, obviously I'm live, so I've dropped him an email. I don't know if he'll get it in time, and I don't know if he's free. If he is, that'd be fab stuff. We'll get him on here, and we'll do what we would have done about a week and a half, 2 weeks ago. Excuse me. Also, there's a couple other creators I've been in touch. Well, I've been in touch with one, and he was discussing another one. So they've both been invited on, but there are massive time zone differences. It's stupid o'clock in the morning for them, so it's going to be a case of, are they awake? And if they're awake and they fancy coming on, I'll get them in here. Oh, just had a super chat from David Oliver. Thank you, David, for £5. Lol, 1st of September is my birthday, Mr. Sensible. Well, and a big thumbs up. I hope you have a great birthday, David, because if what I want to happen happens, I'll be having a great day. So fingers crossed for both of us. Yes. Sorry, I just thought we got a message there. Yeah. I want to talk about a couple of other things. I had a message from one of my patrons with what at face value sounded like a cracking idea. It's not something I could do, but I said I'd mention it in case anyone else thought of doing it. I've subsequently received another message from him thinking it's unlikely we'd be able to do it with equipment that we'd be likely to have to hand. However, I will pass on the idea anyway, and then perhaps anyone can give their thoughts on it, and maybe it's something that one of you guys can do. What he suggested was, at one point in the year, taking an image of a starfield. I think he was talking about aiming it at Polaris. Yes, I think that would make sense, but aiming it at Polaris, and then 6 months later, take an image of the same part of the starfield. So yes, it would still have to be Polaris. It still could be in view at night. With a camera upside down. Actually, you wouldn't need to do that. You could just turn the image. But basically, take the same image again and take it into graphics package and see if you could identify any parallax to the stars. He subsequently came back to me and said that he doesn't think that's going to be possible. Well, obviously, astronomers can do that sort of thing and measure parallax. Whether that's something that's within the capabilities of anyone in our community, I don't know. But it sounds like a fascinating project. We got Blue Marble Science doing his Cavendish experiment. I'm doing my Mage balloon experiment. So I put that out there. It's not something I can do because I don't have the know-how or the equipment or the time, quite frankly, to do that. But maybe someone does. So even if it's not someone in here, if you mention it to other creators, perhaps there's a creator who does quite a bit with astronomy and could look to do something like that. Because that would be interesting, really would. Because obviously, if you can show parallax, that's certainly showing the stars aren't something fixed to a dome. Otherwise, you wouldn't get parallax. Interesting stuff. And it's a possibility. I just not... Oh, hold on. Cracking job. We've just got ourselves a visitor. Mr. Johnny the Orbital has arrived with about 5 minutes notice. That's fantastic. So what I'm going to do is quickly change the topic name then from guests maybe. Where's the text gone? There we go. Mr. Johnny Orbital. And like I said to him before, I think his name is absolutely fantastic. And it always reminds me of, what's that cartoon? The Jetsons. I can imagine Johnny Orbital being in the Jetsons. So I'll get Johnny on in a few minutes' time. It'd be nice to have a chat to him. I did have a chat to him in the waiting room after that abandoned stream. And he seems like a nice guy. So that would be really interesting. I'm really, really glad that Johnny's been able to make it, as I said, especially at such ridiculously short notice. B-ball for life, you're going to quit smoking, you're going to quit smoking. Well, that is what I'm looking to do, B-ball. I'm not going to go into it too much now, but that is what I'm going to look to do. But as I said, we've had some absolutely horrendous, almost unbelievable pressures on myself, Mrs. Sensible and the family. And a major one of those is going to be disappearing. There's a shed load of other stuff, but with this out the way, it's going to change my life. So it seemed to me to be a good time to look to do something. It's not going to be easy, and I will be looking for support and from everyone. Yeah. All hail the Dark Mage. Arctic Haze, one of the patrons, one of the sponsors of Mage. Yeah, Mage is dark, isn't it, Arctic? Hopefully we'll have some sort of announcement in just a few days. So what else have we got in here? Someone's talking. Heat Shield's talking about. About the notifications thing. Also, dropping a couple of videos in a watch later folder. Yes, that's a good idea. So YouTube knows that you're interested in the channel. That is a cracking idea. Got to be worth a try. Parallax was the first flat earther, apparently. Parallax was a pseudonym for Samuel Burley Rowbotham and his book Earth Not a Globe. Unfortunately, it was full of a right load of rubbish, misunderstanding and flim-flam, which is what he was. He was a flim-flam man. What's this? Yeah, heat. Hopefully, well, I haven't thrown the chains off yet, but we are that close. So thank you for that. Right, so I said about that parallax experiment. So if anyone can think of anyone who might be interested and have the capabilities of doing something like that, please pass it on with my blessing, because I'd like to see that done. As I said, it's just not something I'd be able to do at all. You need a Mage emoticon. That's a good idea, Doctor. I need more members because then I can have more emoticons. Yeah. Right, so that was the one thing. The other thing is, quite a number of months ago, I opened the channel to let people submit 1-minute debunk videos. And I'm going to do it again. So for those of you who had the misfortune of not being subscribers at that time, what it is anyone can do a 1-minute debunk video. They don't have to be a creator. It could just be Joe Bloggs with his phone and a whiteboard, a piece of paper or anything, whatever's applicable, making a 1-minute video debunking something about the flat earth or other conspiracies. The only thing I'd say is not political. Okay? So I'll open it to people. I haven't thought of an exact close date. So if anyone would like to do that and have their video shown on this channel, please do it. All I'll ask you to do is email me a link. So what you do is you create the video, make it unlisted so nobody else can see it, and then email me the URL to the video. When I've got a bunch of them, enough to make a show. Oh, hold on. When I've got a bunch of them and to make a show, we shall do that. And I've just had news. I can't see him yet. Oh, yes. I'm going to change that topic again because we've got not one, but 2 people that were invited. This is interesting. Let me update it. So what we've got is Johnny Orbital, who is an ex-flat earther. I'm going to have to move that a bit, resize it. Yeah, we've got Johnny Orbital, who's an ex-flat earther, and Kyle Adams from the Flat Earth Institute. So we have the 2 of them. This is going to be really interesting. Kyle, I hope that you'll bear with me for a little while in that Johnny was a guest who didn't get on previously. So I'm going to bring Johnny on first, and then if you're up for it, we'll get you on then, Kyle, and we will have a chat. We'll fill people in about the discussions that have happened on a Discord, and we'll have a nice chat about that. Right, so hopefully he's all set up and ready to go. Let's bring on Mr. Johnny Orbital. Hello, Johnny. Hello, Johnny. He's not saying anything. Johnny. Right, what I'll do...
Sorry, yeah.
Hello, Johnny.
Hello, Johnny.
I was trying to put a bloody message in your chat and my phone kept going...
Okay, Johnny, you'll have to switch off the speakers because we're getting it fed back through your mic.
Right, sorted. Done.
Cool. Right, at last, we get you on the channel, sir.
Yeah, how have you been?
Not so bad. So my deepest apologies for last time when YouTube we're playing a blinder and screwing not just me, but other channels up. But we finally got you on here, so we'll have a bit of a chat. I did say just a moment ago that you are an ex-flat earther. I know we've chatted a bit, but I just wondered, do you want to tell us a bit about yourself?
Yeah, I mean, when I was kind of going into all the flat Earth stuff, it did all start off with obviously other conspiracies. It started with watching Zeitgeist. I'm sure everyone's heard of Zeitgeist, and it just sends you on a bit of a spiral. Then you just start, everything's a possibility, everything could possibly be a mystery, and you just kind of go along. I ended up finding, like, Antarctica seemed mysterious to me. It was just one of those things. I was looking into Antarctica. To be fair, I didn't really look much into Antarctica before I stumbled upon flat Earth, and then it was obviously you get into. I think everyone's seen the Eric Debay video, and obviously that was probably one of the first I watched.
Yeah, he's got a lot to answer for, that guy. And in fact,
today,
Johnny, I have just done a video about Eric Debay. That'll be out in a few days. Yet another one. But yeah, carry on.
Well, to be fair, in about 3 or 4 years ago, I think I did it might not have been that long. It might have been 2 or 3 years ago. I did a full write-up myself on every single one of his. Well, I'll say there's only about 30 proofs in there, just said in different ways, 200 times like. But I even did that myself. And like I say, the main thing that it was for me is because I'm not over scientifically literate. I'm not clued up in all the sciences, so that's why the way these flat Earth proofs are presented, they are quite convincing to the unscientific mind, and it's so easy to follow, especially when you're conspiracy minded anyway. Because I love a good conspiracy. I mean, who doesn't love a good conspiracy?
Absolutely. I mean, I love TV shows that have got conspiracies. Absolutely, they're interesting. There's twists, there's turns, there's interesting stuff.
Yeah. So it is attractive to, especially when you've watched something like Zeitgeist, and then you think that there's possibilities of everything could be. You do realise that things could be lied about, and then you do just follow the path. And when the proofs are put across in the way they are, I mean, now the only way I can explain it is in the manipulative way they put across. They do convince you.
Yes. So how long were you sort of on the flat Earth scene then?
Not too long. I mean, luckily I didn't find the Facebook groups, because I've got a strong possibility, knowing myself, if I'd have found the flat Earth Facebook groups before I got out of it, I'd have probably dug my heels in like they all do. And because there's so much abuse flung from both sides, to be fair, there's probably the same amount of abuse both sides. If someone's just stood there calling you an idiot and telling you you're stupid and saying where you're wrong, you just dig your heels in and, well, you're an idiot. And it just turns into that childish thing you see all over Facebook. But for myself, it was Chicago over Lake Michigan.
Yeah.
That was one of the things that had me. It was one of the three main ones that kind of had me hooked. There was the
fact that you could see it when it was too far away to be seen.
Yeah, well, yeah, there was the fact that that Joshua Nowicki had caught the whole skyline, and it's like, well, yeah, I'd never really looked into refraction. I'd never looked into anything. I'd just Rob Skiba say you shouldn't see it from that far, and just took it on board pretty much.
But of course, the problem is you can only see it under rare atmospheric conditions. If the Earth was flat and you could see it like that, you could see it all the time.
Oh, Chicago over Lake Michigan is one of my most researched things now, and yeah, I can pretty much tear the flat earther apart using it.
Yeah.
But yeah, it was the fact that it.
Oh, hello.
Oh,
Johnny, you're breaking up a bit there, pal.
not because it's never seen inverted, and literally within 20 seconds of him saying it, on his video behind him, Chicago started inverting. So I started looking into it. Well, why would it invert if it's not a superior mirage? And there's not really much other reasons for it to be inverting the way it does if it's not a superior mirage with, due to atmospheric refraction. So I looked into it a bit more, and I realised from that point that he was either completely unwilling to research himself.
Yeah.
Because obviously superior mirages aren't necessarily always inverted anyway. So the fact that sometimes the right way up has his argument doesn't really hold water, if you excuse the pun. But yeah, so it was realizing that he was either unwilling to research or purposely misleading. So he looked into it more. He found that there are plenty of videos of Chicago inverting, and like you said, on the clearest, calmest, highest visibility days, you just don't see it.
Yeah, and that's exactly when that'd be the exact time when you'd be more likely to see it. Nothing's there to interfere with it.
Yeah, absolutely. Which is when people are showing pictures. I'm like, well, if you look at the fact that the sky is red, you're either looking at dawn or dusk there, where obviously refraction's at its highest.
But also, I don't know if you're aware, Johnny, but what I saw the first time I came across that and looked into it at all was news reports. It was newsworthy on the occasions when it happened.
Yeah, I say that to him. I say whenever they bring up Chicago over Lake Michigan, they're like, it's always there. I'm like, if it's always visible, why would it have made the news? Everyday occurrences don't make the news.
Yeah,
it's and they do. I mean, with a lot, I mean, obviously you've done this a long time, and you realise that what they do is they give a proof of the globe and say that it proves that the Earth's flat. A lot of them, a lot of them just do act like children. Some of them, you see, coming from inside, I realise that there are some of them that are genuine, that are either just confused.
Yeah,
I find it hard to believe that anyone who's researched it believes it, but it's just an easy thing to follow. It's an easy bandwagon to jump on.
Well, the thing is, Johnny, sorry, go on.
Sorry. Go on.
I was just going to say, you said there are people who are genuine but confused. Those are exactly the people I want to reach, to make them at least look properly at the other side and question. Because I feel that if they are genuine and they genuinely look at it and genuinely question and genuinely try to learn, then they will get cured of it, for want of a better word. I mean, you were obviously a person who, to whatever extent, was persuaded by a flat Earth, but genuinely persuaded, and that's fine. It's not a problem to be wrong about something, because what you've done, obviously, is you looked into it, you learnt, realised it was mistaken and moved on. That's absolutely amazing. That's what we want. I know that different debunkers do it in different ways. Some people just laugh. Some people will call them chuffing idiots, without holding back at all. And I suppose that might reach some people. It's just not my style. It's just different style. I'm not criticising them. It's just different style. But I think that all of the debunking community wanted to debunk this stuff so that people aren't just following it blindly and falling into worse conspiracies.
Yeah, I mean, one of the worst things I see on Facebook, to be honest, is the religious side of it. I mean, the people using other people's faith against them to get them involved in this thing that...
Can I ask you, Johnny, are you a religious person?
No. I mean, I was brought up Catholic, Christian, used to go to church every Sunday and everything, but around about 13, 14, the age of logic and reason, that all kind of went into the bin. It was just not something that I entertained. Now, in all fairness, to show how kind of conspiracy-minded I am, I suppose, the fact that I'm not just one of these guys who, I've learned a bit.
Oh, you dropped out again, Johnny. Hello?
Sorry, my phone does that. You got me?
I got you again.
Yeah, sorry, my phone does that from time to time. Once every hour, it'll just cut off for about 3 seconds. Don't know why it does it. It really annoys me. But yeah, so it's like with religion. I'm not a religious person, but I do think that it's just as stupid to dismiss these holy books as it is to take anything in them literally. They are all metaphorical as far as I can see. But to cut a long story short, the way I see religion is we're traveling through space as a species. Imagine us in 50 years, imagine us in 1,000 years, imagine us in 10,000 years. We might find another planet with primitive life. we might descend from their heavens and teach them the art of education, multi-story building, farming, domesticating animals, all the things that are attributed to gods now. And we might leave them and ascend back into their heavens, tell them we'll come back one day. And that seems a logical possibility. You know, we could do that in the future.
Yeah. I mean,
And
leaving
that
aside
could have
the
been what
getting
happened
to
with
these
us.
places, certainly if we visited somewhere, I'm sure that we could well be treated as gods under those circumstances. Yeah, I see exactly
they
where
could
you're coming
possibly
from.
write about us for thousands of years, and you know, it's that's how I see religion. That's about the closest I can come to tying religion in with science.
Okay.
Because every religion tells a very similar basic story of visitors from the sky, non-earthly visitors.
I think
So
many
it's
of them.
on.
I mean, I'll be honest, Johnny. I don't really want to get deep into religion because, well, it's perhaps a topic for another day. But you know, I think many religions are actually based on earlier religions. I actually saw a video this evening. I can't remember the channel. It was "What do angels really look like?" And I mean, everyone thinks angels. Oh, these beautiful beings look like us with wings. But when you look at the biblical descriptions of them, with 4 faces and 6 wings and whatever, it's really quite
frightening.
different. Yes.
But no, that's just more of an insight as to.
Yeah.
I'm not just straight down the line, just scientific now. I am open to dodgy, weird, crazy possibilities, but even flat Earth can't keep hold of me.
So how long were you sort of in the? I was just going to say in the flat Earth sphere. You know what I mean? How long were you holding it as a belief, to whatever extent?
I would say not too long. Around about 3 months I'd classed myself as convinced.
Okay.
But it was actually looking into it because that was what I was more interested in, knowledge. You know, for me, it's just getting more knowledge is what attracted me more. And I thought, well, if this is right, then hey, there's a lot more stuff to find out.
Yeah.
If it's not, then and I'll tell you something, I've learned far more science just discussing flat Earth than I have in my life. You know, I've learned a lot about optics and refraction and the way things work. And it's if nothing else, I've got a lot more knowledge because of it.
Yeah, absolutely. I'll tell you what, when I've been doing debunks, I've seen someone's video that says X or Y, and I think, well, that's wrong, and I know it's wrong because of something. To actually debunk it, I've often had to look into it further to get a deeper understanding and explanation. So I have learned a ton of stuff, absolute ton of stuff doing this.
Yeah. I mean, it's rare that you have to kind of look into things nowadays. A lot of it's just been said so many times. It's like I'm in a flat Earth group at the minute on Facebook, which is they'll kick you out if you say anything wrong. So one thing I've learned with debating flat earthers on Facebook is you can't give them abuse. You've just got to take the abuse, not dish out any back, because as soon as you retaliate, no matter what they've said to you, that's when they'll report you and you'll get kicked. So the way I'm putting myself across now is what I'm trying to do is help you guys eliminate proofs that obviously don't work, and then you can concentrate on a bit more of a challenge for us, you know.
Okay. And how are they taking that?
Just well, it is politely patronising, I suppose. So they're taking it accordingly. You know, some of them are all right, but some of them don't fall for it.
No. Well, listen, if you in your travels in that world, if you come across anyone who you think might be open to having a friendly discussion, because I've had flat earthers on here before. I've got Kyle Adams sat in the live waiting room, who is a flat earther, and has been on before. And obviously the fact that he's come back again, he knows that I'm not just going to call him names and mute him and stuff like that. He knows he's going to get a podium to speak on. So yeah, if you come across anyone and persuade them, please point them my way. Tell them that I'm open to this. I obviously disagree with them, but I'm happy to discuss it and give them a fair crack at a whip and explain what they think and why.
Yeah, well, I think I told you the other day in an email or when I was chatting to you, there's a guy on Facebook, or I've got him in Messenger, who was a flat earther, but I could tell that he was kind of in limbo, not too sure. A couple of things he was questioning. He did sound genuine, so I kind of got him in the inbox. I just said, look, come to my inbox, away from all the egos. So you know that I'm not just doing this to get likes on my comments. come and speak to me, show me, give me any questions, and I'll happily explain them to you. You know, I've been where you are. I understand the confusion, and I know that they're convincing. I've worked. So at the end of it, he ends up saying he was no longer a flat earther. And I did message him back saying I hope I had a part to play, and he says, yeah, you've got a vast knowledge of this, that, and the other. Like I say, I'm not the most scientific guy in the world. I'm really not. But you don't really need to be. You can do all this with logic. You can get yourself out with logic.
Some proper research. But absolutely. Yeah. Well done you, Johnny, for that. You know, as you said, even if you're just a part of it, that's something to be proud of, because he's now no longer following a mistaken theory, for want of a better word. A theory without evidence, of course.
It definitely needs a better word.
Well, look, what I have in the waiting room, as I said, I don't know if you spoke to him at all, Kyle Adams. He is a flat earther, Johnny, and he's got a YouTube channel called Flat Earth Institute of Science. Now, recently on my Discord, Kyle was chatting with other people there and working their way through a set of questions, and I found it quite interesting, so I jumped in as well, and we were talking about satellites and then the firmament. So what I'm going to do, and I don't know if you want to hang around on here, Johnny, and perhaps in a while you can chip in and ask Carl some questions or put some evidence in.
Yeah, no problem.
Yeah,
no problem.
Okay. You know, you're obviously a nice, friendly guy. Kyle is as well. Yes, I think he's totally mistaken, but he seems like a nice guy. I've got no reason to dislike him or mistrust him or anything like that. So I think this could be quite interesting. Right, let's...
No problem.
Hey, let's bring in Kyle then. Hello, good evening, Kyle. Can you hear me?
I can hear you.
Brilliant. Are you okay then? Obviously, we were chatting, was it yesterday on Discord, I think it was? Can we just give obviously not everyone watching a video or watching the stream is aware of the chat, but if we can try and sum it up. You were questioning about the thermosphere, the temperature in the thermosphere. How else could you expand this? Because I do not want to put words into your mouth at all.
The temperature of the thermosphere. I shared a video a while back about the thermosphere and some of the major issues I saw going on with the thermosphere. And so that, are you asking for how I got to the series of questions? Background.
Yeah, we went. Okay, what were the questions? Let's quickly run through those, and I can say how I answered them.
Okay, yeah, I have that right here.
Oh, the first one gave some figures for the temperature in the thermosphere, and you asked, did we agree with them? Didn't you?
Yeah, I've got my questions right here. If you want to go through each one of them.
Okay.
So, yeah. So the very first thing I did was I presented an article about the thermosphere from UCAR, the Center for Science Education, and it went and described the temperature of the thermosphere. It says temperatures in the upper thermosphere can range from 500 degrees Celsius to 2,000 degrees Celsius.
That's right. And you're asking, did we accept that? And I said, yes.
Yes. Yeah. So you said that you'd accept that, and I was talking to some other people, and I got one person to answer, and the other person just absolutely refused to answer. And then we went on to the second question here. And our second question was simply, you agree that the sun's radiation causes the temperatures to get that high? Yes or no? It's just quick, easy, yes or no question.
Yeah, and I said yes. And people were chipping in because of this style of discussion, weren't they? But okay, I said yes.
Yes.
And the question 3?
And the whole reason I needed to do this. Okay.
Yeah, go on. The whole reason.
Question 3. Okay, the whole reason I needed to do this was because I just shared my video and just said everything straight up front, and everyone kept attacking it with these imaginary arguments that they're trying to attack. They're saying the thermosphere, they're acting like I said, the thermosphere would be burning people up and it would be burning the satellites and everything up there. I'm like, that wasn't my argument.
No,
and
but
so
I do know where they're coming from, Kyle, because plenty of times the argument has been put forward that because the thermosphere has that temperature, everything, satellites would melt because the materials can't stand that temperature. And of course, the reason why is that the thermosphere is very, very, what's the word? There's hardly any material there, so there's not enough to transfer heat. And examples often given: stick your hand in an oven at a couple hundred degrees. Yeah, it feels hot, but it doesn't burn you. Stick your hand in a pan of boiling water at 100, and you'll feel it. So that's why they were racing that.
That's what everyone kept saying. They kept pointing at me. I'm like, wait a second, that's addressing an argument that I never made. And so
fair enough.
I'm not saying it's the thermosphere that's burning people. And so and so that's
so
why
at that point we moved on to, what was it, question 3 then?
Question 3 says, the temperature of the particles in the thermosphere is really high, it can't burn anyone because they are too far apart. Do you agree, yes or no? And so that's where it's addressing that this is not that argument. Does that make sense?
And I agreed. I agreed, yes.
Yes. And then we had question 4. Molecules that make up the satellite are really close together. Do you agree, yes or no?
Sorry, molecules making up the satellite are close together. Yes, they are.
So that's why they're solid objects. Then we went on to question 5. The molecules that make up a satellite are really close together. Their temperature should get really high. That is why they're so high enough that they would be able to burn you or burn something.
And that's when I said, but satellites have cooling systems.
Yes.
And of course, they can't use conduction or convection to get rid of their heat because there's not enough material there. They have to use radiation and radiate the heat away.
Yeah. And so we both. So that was really great progress right there, because here we got to a point where we agree that the sun, the same thing that's making the thermosphere get really hot, is the same thing that's going to cause the satellites to get really hot. So there's an entire point that the satellites have the cooling systems in the first place, and that was a new place that I've gotten to with all of the different globe earthers out there, because everyone was ignoring that satellite thing, and so I'm like, oh, good, this is new grounds. Now I can feel like I can finally progress here.
But then it was at that point, I think, we started talking about the firmament, wasn't it?
Yes, the firmament. That's where we.
So can I
don't remember exactly what transition to that.
No, I can't. I can't either. So that's pretty much brought people up to speed. I did want to ask you. I was thinking about this yesterday, Kyle. I want to ask you excuse me, a couple of questions about the firmament. I'm going to lead you with some questions now. Do you think that the firmament, whatever it is a solid thing? It's okay. So it's made out of material. And do you think the sun, moon, planets, stars are inside, outside, fastened to the firmament? You know, how would you sort of envisage that?
I'm with deep in the rabbit hole, DITRH. We both agree with that they are not under the firmament, but they're actually like within the firmament, like in a pocket somewhere. I'm not really sure exactly. I'm trying to think of the best way to describe it here, but either in the firmament or above the firmament.
Okay. Why do we need a firmament? Or why would we need one?
I don't know. Yeah, I'm not the designer. I'm not the one who put it there.
No, okay. Because I'm assuming that you don't disagree that there is a pressure gradient from, the atmosphere pressure down on Earth is 14.7 pounds per square inch. The higher you get, the lower it gets.
I talk about that in one of my videos there.
Do you agree that there is a pressure gradient?
Absolutely. And there's a lot of people out there who are saying, well, how can you have a pressure gradient inside of an enclosed system? And I've heard that argument so many times of like, what are you talking about? What about an enclosed system would make it impossible for a pressure gradient to exist? Like if I were to put oil and water in a container.
Yeah, sorry, go on.
So if I were to put oil and water inside of a container, they're still going to separate. There's still a pressure gradient going on inside the container.
Those are different densities, aren't they? Those are different materials, different densities. The atmosphere is pretty homogeneous mix of nitrogen, oxygen, carbon dioxide, and so on. Okay, put it this way. Let's say you had a container and you had an exact number of slightly squishy rubber balls that filled it. You just put them in, okay? So they're not under any pressure. The ones at the bottom would be squished a bit by the weight of the ones above, but not by much. Now, that would be an equivalent of atmospheric pressure. It's just the weight of the ones above. Now, if you got more squishy rubber balls and stuffed them in, okay, they'd all be pressing against each other harder and harder. But the ones at the bottom would pretty much be the same, have the same amount of pressure on them from being squished as the ones at the top. So what I'm saying is, if you have atmospheric pressure, there's nothing forcing that level of pressure. It's just the weight of the atmosphere above. Whereas if you took like a gas cylinder, if you had it, if you started pumping more and more gas in it, increasing the pressure, the only way, gas pressure equalises, so it's going to be pressing equally on the top, the bottom, the sides.
Okay.
So that's why gas pressure is different than atmospheric pressure. So what I'm saying is, if you don't need a dome or any sort of lid to keep the atmosphere to Earth, because gravity is keeping it to Earth. It's not.
Is that where the gravity argument comes in?
That's what talking about. Yeah, that's why so many flat earthers hate the idea of gravity. But
I've had that. Like everyone's like, "Oh, well, what about gravity?" I'm like, where does gravity fit in here? I've been making these big boards of all of the different flat Earth arguments I can find, and I can never figure out where gravity fits into anything. It's just a random piece that just isn't connected to anything. Like, where's the connection?
Okay,
so
Carl,
maybe that's it.
If you've got a balloon and you're just holding it, the whatever small amount of air there is inside is under the same pressure as the pressure around you. If you blow up that balloon, you've increased the pressure in that balloon, haven't you?
Yeah.
If you let go of that balloon, that air will rush out. It will equalise.
Okay.
Yeah. So they're saying that you have to have that as a container. Well, yeah, let's say we got 14.7 psi down here at ground level. You put a couple of pounds of pressure into that balloon, so let's say it's 16.7 in the balloon. When you let go, it will equalise, so it's 14.7 outside and 14.7 inside. So they said you have to have a dome, otherwise the atmosphere would rush off. It would equalise with that of your so-called space, which is virtually zero. But that would be true if you took that 14.7 and put that in an area of space, an area of zero, it would instantly disperse. The thing is, when you're getting up towards space, that pressure is getting lower and lower and lower until it is the same as space. Because you think the 14.7 that we've got at sea level is higher than whatever the pressure is at the top of Everest. But the 14.7 at sea level does not rush up to the top of Everest. It wants to, but gravity's holding it down.
Mm-hmm.
Johnny, what do you think of all this? And sorry, I don't know if you've met. This is Johnny Orbital. Johnny, this is Carl Adams.
How are you doing, Carl, mate? Okay.
Oh, are you a globe earther? Are you a flat earther? Maybe about yourself.
No, I'm a glober. I was a flat earther for a short while, many years ago, but no more. See, when it comes to the firmament, the dome, I'd rather not call it firmament. It just seems to be a confusing word.
You can call it what you want.
But it's not really something I engage in. The way I see it is meteors exist, and meteors have evidence of them being not from in the atmosphere with the fission crust that they have. And the only answers I've ever had with regards to meteors from flat earthers is, I've had a ridiculous one saying it's fireworks thrown from planes. I've heard that a few
Sorry,
times,
I've not heard that one before.
Yeah, no, I've genuinely. But also it's parts of the dome breaking off. Now, the thing is we can all have circumstantial guesswork going on, but without any reasoning or explanation as to what the dome's made of, why these meteors that can come from, well, as far as we're concerned, space, have the difference in kind of the crust that they have when they land, because they are recovered, and they're not just recovered by government agents. They are recovered by every Tom, Dick, and Harry. They can be recovered
they can be
by
picked
anyone.
up by anyone.
Yeah, absolutely. So it's like with the. I mean, to be fair, the dome isn't something I get into myself. I'd rather just stick to the actual shape of the Earth. But yeah, there are. The way I see it is, there's lots of evidence of meteors being from outer space. Very little evidence of any dome. And that's pretty much the up and down of it.
I wonder how many different things you've really looked into, or how many different claims about the dome you've heard. Because a lot of people say that without looking into anything. And so I don't know about, but you said you've looked into it in the past and you used to be a flat earther, but yeah, so I've just got to scratch my head on that one, because I just see a lot of different evidence out there for it.
Well, cool.
And I understand this whole thing I understand your question about meteors. There's a lot of different things that we don't really understand, and we can question, and everyone's got doubts and questions, but just because we don't understand one thing, it doesn't fully eliminate all these other things that we do understand.
No, absolutely. I absolutely agree. And a lot of the time when I'm talking about specific things, I'll say to somebody, look, if I make you believe that there is no dome, that doesn't mean that the Earth isn't flat. That just means that there is no dome. I always take each piece individually as on its own merits.
So, Kyle, I'm honestly not being facetious, but I'm assuming that you would not believe in things like Santa Claus or fairies or anything like that. Okay.
No.
So, without evidence for it, why would you believe there's a dome?
Without evidence for it?
Yeah.
I wouldn't believe it.
Okay.
Yeah.
Okay.
I was without, I went my entire life here until I became a flat earther, not believing in a dome, because I'd never heard of any evidence for it. I've got to have a reason to believe it's there before I can actually start believing it.
So what would be the evidence is that or evidence, depending how you use that word, because I've been picked up on saying evidences, but it is valid. But what is the evidence that makes you think there is a dome of some form or other?
Okay. Well, my absolute favorite evidence out there is going to be the Operation Fishbowl explosions.
Can I jump in there?
Please.
Before it.
Okay, so Operation Fishbowl, was that the one where the rocket hit the dome?
Yes. Well, it was
Okay,
it wasn't the rocket. It was the explosion. Okay.
It was the nuclear test.
The military sent up.
It was the nuclear test over Antarctica. Sorry. Go on. You speak, Johnny. Go on.
Sorry, mate. When I've seen that recorded, it was at a height of 70 miles. The explosion happened, or the contact happened, whenever it was, around 70 miles. Now, with the kind of most accepted flat Earth model has the sun at 3,000 miles high, but the dome at 70 miles. But sometimes the sun is inside the dome. Sometimes the sun is as low as 11 miles. There's quite a lot of contradiction with regards to the Operation Fishbowl.
Yeah. Well, the first thing, I don't know where you're getting all these numbers for how far away the sun is. All that stuff is based upon probably straight lines going through the air. But I can't verify the straightness of the lines going through the atmosphere or through space, as a lot of people like to think about. I've got some great videos here about how the sun is not 93 million miles away, because the only way we could even claim that is by being able to verify all of the matter that the sunlight passes through. And so even from a globe Earth perspective, there's a ton of different solar wind out there traveling around through space. And that solar wind is made out of plasma and a whole bunch of different gases that are totally known to be able to refract light. And so it's all varying at different densities, like all throughout one point and all the way out to us. Does that make sense?
I don't think the amount of matter in the solar wind is enough to refract the sun. You're talking about minuscule matter. I mean, yeah, it's a lot of matter, but in the scale of the solar system, it's virtually vacuum.
Okay, so that's kind of the interesting thing about refraction and light. And so I always like to use the example of a sheet protector. One sheet protector by itself is very transparent. Stack up two, all of a sudden you're losing transparency with every single sheet protector you stack next to each other. And so it might be really, really small in one spot. When you stack that up over 93 million miles, all of a sudden that's a lot of different matter. That's a lot of matter that is got to pass through. Does that make sense?
Well, the whole business of the solar wind varies all the time with prominences on the sun, prominences, an outburst from the sun, but we don't see the sun sort of shimmering or twinkling like we do stars. Any effect is going to be minuscule. But Kyle, we're getting away a bit from the dome firmament, which is where I'd like to have this discussion. But I will just say, I just want to read a super chat from David Oliver for £5 saying that video on the sun is a volcano was hilarious. It was, David. I enjoyed doing that. So, Kyle, that's nothing to do with your beliefs. It's someone else I found who believes that the sun is actually a reflection of a volcano reflected off the firmament. Okay. That idea is way out there. So
there's a lot of pretty far out there ideas.
Okay, so getting back to the dome, and I was asking for evidence for it because I did send you a bunch of questions, or posted a bunch of questions like, what was it? What's it made of? Or can you? How has it been detected? Has anyone got a photo of it? That sort of thing. So, are there any evidences you can point to?
Pictures, real quick.
Okay.
I'll send you some pictures here from the Operation Fishbowl. That will help clear things up a little bit.
Okay, if you DM me, I'll get them on the screen. I'll do it as quickly as I can, but it might be a little delay.
All right. I'm not sure did you get that?
No. Where have you put
just
them?
In the general. Oh, sorry, that's general chat.
On general chat. Okay, 1 second.
Yeah.
Oh, right now my general chat's not updating. I've got a blank screen.
Okay.
Oh no! Hold on. Oh, they're very small images, though, aren't they? I think.
I can zoom in and get you a better one here. Let's see.
You've got chickens in your room.
Oh, they're right outside. Yeah, right outside. I've got a whole bunch. I've got a whole zoo over here, let me tell you.
Well, while you're getting those pictures, and I will post them, they are images of the explosions in the Operation Fishbowl. I think there were only 2 detonations for Fishbowl. And Kyle's point, because he has made it and I've seen it, is that the shape of the explosion is a ring, and compared it to throwing a water balloon against a brick wall, and you'll see the pictures in a while, which is also a ring. And I wouldn't deny either of those, but I wouldn't say that's evidence or anything. It's just one thing. Sorry, I'm just laughing at your chickens.
I'm sorry, it's okay.
I say it's just 2 things that
like
look similar.
About it.
Yeah, all I can hear is chickens.
I'm going to change the topic to Mr. Sensible Talks to Chickens. Okay, so Carl, you're going to try and get those images. That'd be great.
Okay.
But just because one thing looks similar or has similar aspects to it than to something else doesn't mean it's the same.
Okay.
But I would also have to say,
I understand, and so I can kind of point to taxonomy. That's what it's all based about, studying animals and their relationship with one another, right? And so we kind of, whenever people are trying to figure out the different species, they look for those similarities and they try to connect as many dots as they possibly can.
Well,
so that's exactly
that is
what I'm doing here. And this is just a couple similarities.
But I would have to point out something. The heights of those explosions, off the top of my head, was something like 26 and 90 miles. I think it was something of that order. So if this firmament is there, and is tough enough to withstand a nuclear explosion and cause the explosion to be deformed so it appeared as a ring. It's got to be some pretty tough stuff. Why can't we detect it? Why have we never detected it with radar or something?
Well, we really can detect, because we can, as we said, this is one thing. This is one dot that I'm connecting, and with the nuclear explosions, that's one dot. The second dot here that I've got is about the bouncing radio waves off of that. With the skywave technology, they're able to bounce TV signals off of that. They don't need satellites for it. They can just bounce it right off of the firmament.
Well, you know, they bounce signals off of the ionosphere. Oh, pardon me, excuse me. And that is weather dependent. It's like ham radio. So, I mean, I'm not a radio ham, so I haven't got all the details. I have very little knowledge of it, but I know that at times, with the right conditions, they can bounce those signals a fair distance around the Earth. Other times, they can't go so far.
That's the claim.
Well, it's more than a claim. Ham radio can reach thousands of miles. But what I'm saying is, not always.
You're missing me.
Okay, well, let me finish my point, and then you can argue against it.
Go ahead.
So they can bounce radio signals, and it varies the amount depending on the conditions of the ionosphere. Now, if there was a dome that you were bouncing it off, a physical dome, that's not changing. So if you can bounce it, whether it's 1,000 miles or 5,000 miles or whatever, you would always be able to do that, and that's not the case.
Okay, so you're saying that ham radio is unreliable. Sometimes you can bounce a signal off of the ionosphere. That's the claim I'm talking about. Okay, so we're both looking at the same observation, but we have different explanations for the observation. Does that make sense?
Well, what's your explanation for the fact that sometimes radio signals can bounce further than other times then?
The weather, obviously. So the weather's continually
so does
changing.
the dome suffer from weather?
No, I'm saying there's a lot of atmosphere between us and the firmament. The firmament is way up there above the atmosphere, right? And so it's kind of with TV signals, you get a poor reception, and there's rain and big clouds overhead, right?
Yeah. Sorry, just say that again, please.
Yeah, there is poorer reception for TV signals.
Yep.
On Dish Network, for example, when there's rain and other interference going on above you.
On terrestrial TV, with a standard aerial, you talk about non-satellite TV.
Yeah.
Okay.
There's going to be worse reception and poor weather conditions, and so just like you not being able to see as far, there's going to be a lot more interference depending on the weather, and so you can bounce a signal, and so the globe Earth claim is it's bouncing off of the ionosphere, but the flat Earth claim is that it's bouncing off of the firmament.
But we know that the ionosphere, the conditions in the ionosphere change, which explains why sometimes those signals will bounce further than others. But a physical dome, for want of a better word, is not changing.
Right. But the atmosphere below it is.
Right. Okay. But we Do you want to chip in on this, Johnny?
I think the point is that the weather. I think the point you're trying to make there, Mr. Sensible, is that the weather isn't causing the interference; it's the change in the ionosphere. So, if the weather isn't causing the interference and it's the ionosphere, how can the dome then be the explanation for it? If it's not the atmosphere that's causing the interference, I mean, I hold my hands up. I haven't got a clue anything about the ionosphere, anything like that. It just seems that's where the mix-up is. If it's the ionosphere that's changing, that's giving us different results, then it should be the dome that's changing. If it's not the atmosphere and the interference and the rain and the weather and the conditions, and it's just the ionosphere, then obviously that's still a question that would need responding to. If obviously the weather interference is a big factor, then could be ionosphere, could be dome, as far as Kyle's concerned. Mm-hmm. If I'm understanding the the mix up there.
That's the sort of thing I am talking about. But of course, I mean, it's not reaching through atmosphere. We can send a signal through atmosphere. That's not the issue. For instance, I nearly said something I shouldn't. I'll have to think of another example. But it's something to do with Mage, so I'll leave that. Tuss says there's a number of amateur radio users in chat. You could bring one in. Yeah, maybe. I mean, I'm not a radio buff. Johnny's just said he's not, and I don't know, Kyle. I'm assuming you're not either.
To think about. Here's something to think about. Okay, so both of us are in agreement. We've got a signal that's going way up there, and it's bouncing off of something up in the sky.
Yes,
it's bouncing. And that means we should be able to detect it on radar. Do you agree with that?
I don't think you could detect the ionosphere on radar.
Not.
And anyway, with radar relies on it reflecting, not bouncing off and go. Well,
reflection and bounce.
You need the reflection to come back to you.
Okay, and you don't think that happens with TV signals?
Sorry, how do you mean?
Okay, so we both were just barely in agreement here that we're sending a TV signal up into the sky and it's coming back to us. That's the way ham radios work, right? So we're both in agreement upon it going up into the sky, and you can say reflecting back, you can say bouncing back. Either way,
it's not back.
It's going up into the sky and it's coming back.
It's not bouncing back to the person who produced it. It's not a mirror facing straight onto you. It's more like going up at 45 degrees and going down at 45 degrees.
Okay, so it's not.
So radar would, if radar can be affected by the ionosphere, and I don't know, but if it can, that also is going to be bouncing away from you. You're not going to get the return signal. For it to return, you think of stealth aircraft. There's still a physical aircraft there, but because of all the clever angles, apart from the materials, but the clever angles that the body is made up are designed so that when the radar signal hits them, it will bounce off them, but it won't reflect back to the the radar station that's produced the signal, so they don't see it.
You're claiming that a radar can only detect a cliff out in front of you if it's going directly at it. If it's approaching a cliff from an angle, it's not going to be able to detect it. Is that what you're claiming?
Well, there are such things as radar shadows, and there's I did a thing about sonar as well, which I suppose is much the same.
Sonar and radar, they're very similar concepts here.
Because you get I can't remember the proper terms, but there's when they're searching the bottom of the ocean for say a shipwreck or whatever, they're using passive and oh god, I can't think of the other word. Someone in chat, please let me know. There's passive sonar and the other one was listening out, wasn't it? Listening out for enemy subs. That's different. So forget that.
So my whole point here is just that if we can send a signal up into the sky, it can be reflected back down to us. We should be able to detect it with radar.
Detect the ionosphere?
Just detect the thing that's reflecting the signal back at us.
Well, but it's not reflecting it back to you.
Okay, if we were to have another transponder somewhere else out there or receiver,
then perhaps you may be able to pick it up. Yeah, you may be able to pick up the radar ping, but
that's another issue entirely too, because radar signals themselves can also be refracted, and that was one thing that it goes into it. The atmosphere refracts more than just sunlight; it also refracts radar signals. And so, if we were to try and get an exact, you might be able to detect it with radar, but wouldn't be able to know exactly how far away it is unless we knew exactly how much it was being refracted. That presents kind of another issue there as to why we don't know how far away it is. Does that make sense?
Well, where we are with this is we've still not had anything that can detect a physical dome, because we're talking about signals bouncing off it, as in ricocheting, if you like. Now, how about if you pointed your radar 90 degrees upwards, you should get a reflection if there's a physical dome, because the signal will go up, hit the dome, and come back down again, and you'd pick it up.
It depends on how straight the dome is. So that really is dependent upon that.
Well, the radar is going out. It's waves, isn't it? It'll be going out, getting wider. But at some point, there'll be a reflection that comes back to you if there was a physical dome.
And that's kind of what we're talking about here, is how you can send a signal up, but it doesn't come immediately right back to us that are aware of. Maybe you can, maybe you can't. It's kind of hard to describe all this when we can't point to actual observations of this happening. Does that make sense? So that's something I'd love to further investigate about this whole reflection of the ionosphere, or as a lot of the mainstream scientists are calling it. But
sorry, you're
one
not
of those things that
are you not accepting that there's such a thing as the ionosphere?
I think there's a lot about the ionosphere that is very much in line with the description of the dome. There's a really great video out there about, I think Rob Skiba is the one who produced it, and he found an article talking about the firmament. It was either Rob Skiba or the Flat Earth Brothers. One of them produced an article where they specifically described, I'm trying to remember it was like Duke University or something like that, where the scientists were like, oh, well, there's like a shield way up in the sky. It's like a solid shield that's reflecting things back at us and reflecting the dangerous things out. Wish I could. It's hard to do this without pointing to it. I might be able to find it. I don't know. I'll keep it in mind.
So I've seen a document about Antarctica where they say there are ice domes.
That's a different thing, though. They've taken that word,
Yeah, I don't
Johnny.
think I've seen anything about them saying there's something above us.
Yeah, I've seen them see that. I think it was something to do with one of Admiral Byrd's reports, and he used the word dome, and they've jumped on that. But that's no more than a formation.
You're thinking of the encyclopedia entry. There's that encyclopedia entry about seeing a large dome way down in Antarctica. But
that's just the naturally forming ice domes, isn't it?
Yes, but it's not like an igloo or some sort of hemisphere like that. It's a solid area where the ice is high, like a hill almost. I have been given a super chat by Cheshire Cat for $4.99. I think this is it's aimed towards you, Kyle. It says, ask why the Kármán line is 62 miles, but the dome is 3,000 miles. So they're still they still have the vacuum without a container problem.
Apparently, he kind of missed the point here about saying, I don't know how far up the dome is.
Okay. Right, so if you don't know how far it is, and there's no direct detection of it, it's not been seen.
Yeah. How are you defining direct detection? Because I just gave you two different ways of directly seeing.
Go on, just mention each one of those again. What, radar is one, is it?
Radar was one of them. It was.
And your second one is?
There were the nuclear explosions. That was number one.
Oh, nuclear explosions.
The second one I gave you was skywave, which is ham radios and all these other things that are reflecting off of a big giant thing in the sky.
But they're not.
So that's two.
They're reflecting off a layer that's ionized gas. So I think it's about 60 odd miles up, and
that's
quite
what the
thick.
Globe Earth claim is. And so that we end up getting into a lot of different things here, where we're both seeing the same observation, we're describing it in different ways. We both have different explanations for that same observation. And
Well-
so that's what we're looking at.
Well, Johnny made the very good point about meteors. They would have to pass through a dome. Whether that dome was 60 miles or 3,000 miles or 10,000 miles up or 100,000 miles, those meteors would have to come through it.
Unless they're already over on our side. A lot of different questions
So,
here.
sorry,
about
say that again.
meteors,
Say that again.
Unless they are already underneath the dome.
Well,
So what
that's
would
not
cause
the
the
case.
crust?
They've tracked meteors for a long time. Tracked asteroids because they talk about it's a near miss. It came between the Earth and the Moon, or it came so many thousand miles above the Earth. But they track them for months because they're looking out for the one that could hit this Earth. And if they were under a dome, I don't know. You said you don't know exactly how high this dome is, but let's say the dome was I don't know, 100,000 miles high. That would mean, though, that all those meteors have to be flying around within that dome.
Yeah.
Well, so they'd have to be in pretty stable orbits generally, and we don't see them.
Yeah.
Well, we don't see them, do we? And yet we can
I
see.
didn't say we did. I was just
No,
saying,
we
yes.
don't see them within that sort of small area, but we can see and track asteroids from much greater distances.
And what possible reason would there be for the crust that it's called a fission crust from when they burn up in the atmosphere? So they get like it's called a fission. Like I say, I've not looked into it too deep, but I remember looking into how we know that meteors come from not from within the atmosphere, and it was to do with the fission crust that's on them. So what would cause a fission crust on a meteor that's just floating around above us, essentially just in the sky, and then fall into Earth?
I can't say I've heard of the fishing crust yet. That's new information for me, so I can't really answer a lot about that.
That's fine. But it is, like I say, when I was looking into how we know that meteors, because obviously I've asked the question before, how do meteors get through the dome? And it's like, well, they're just parts of the dome. And I've said, well, okay, so I've looked into it from that point, and it's like, well, how do we know that they're not from Earth? So obviously, if you've not looked into it, I'm not obviously going to try and press you on it, but one thing I would suggest is look into how we know meteors are not from Earth and not from within our atmosphere, and how we know that they're from space, and how we know what happens to them as they come through the atmosphere. And then obviously look into that, see if you can find any flaws in the explanations given, and then obviously it's a point that can be taken up another time.
The meteors are one I really want to do a whole lesson on. I'm okay.
Right,
Meteors
Kyle,
are something
Kyle,
I have looked at. Go ahead.
Kyle, just to interrupt, about meteors, are you talking about meteors as in the odd random one we get, which may or may not make it through the atmosphere to become a meteorite? Or are you talking about things like, and someone's pointed this out in the side chat, the regular meteor showers?
Myself, I mean meteorites, I do apologise. Terminology problem. The ones that land, we obviously can find them, see that they've got the
crust,
fission crust on them.
But Kyle, you've got, let's think, is it, I can't remember the name of them, the ones in August, Perseids. Every year in August, around August the 12th, you get the Perseids meteor shower. Have you ever witnessed them? Have you
I wonder if
witnessed...
I saw that. I wonder if I saw. No, that was the asteroid.
No, I'm talking about the meteor showers that look like a star that flashes for a sec, a shooting star. But you get, I mean, that's what they're colloquially.
I've definitely seen meteor showers before.
Okay.
I can't say I've seen this one.
So, okay, that's fair enough. But Perseids is the biggest one of the year, or tends to be, and I think every 33 years it tends to be much better than other years.
Do they ever become meteorites and actually hit the ground?
No, they're too small. Well, I mean, I suppose. Yeah, we're talking.
Kind of gets into the whole because there's two different kinds of things here. There's the wandering stars, as we flat earthers call them.
Those are planets.
Planets. but there's a lot of comets and other things out
Yeah, they're not
there
one. Yeah,
that just look like stars
sorry.
that are wandering.
Terminology. Comets are in very elliptical orbit, or tend to be in very elliptical orbit. Certainly, the ones you're likely to see, because they got to get closer to the sun to start melting, so they leave a tail. Wandering stars is just the name, the colloquial name for planets, because they look like stars, very bright, and they seem to wander around, whereas other stars, your ordinary stars, appear fixed. Now, I'm talking about meteor showers. That's where you get these bright flashes that streak across the sky, and you'll only see them for a second or two, and they come round. Yeah, you can get meteors happening any time of day or night. Obviously, you won't see them in the day, but the meteor showers are regular as clockwork. They come around every year. Do you know what they are?
No, but I don't know what half of the stars out there actually are.
They're dust. Yeah, when you see like there's the Geminids shower and Perseids shower, those shooting stars that you see are tiny. We're talking about things sort of up to about the size of a grain of sand, instantly turning to plasma because they're hitting the atmosphere so fast. They are dust from the tails of comets. And the reason we can predict that, for instance, the Perseid shower happens every year around August the 12th is because that is when the Earth, in its orbit around the Sun, intersects what was an orbit of a comet. And I think it was Swift. Is it Swift-Tuttle? I'm not sure if it's Swift-Tuttle for Perseids. So the trail of dust will follow the orbit that the comet went in. And over time, that dust will spread out across the whole orbit. But there's a hot spot, if you like, which is closer to where the comet was. And in the case of Geminids, Perseids, every 33 years when we pass through that tail, which we do every year, but every 33 years we pass through the thick bit. And so you are very likely, not guaranteed, but very likely to get a very good meteor shower.
So NASA has all these really old and very detailed explanations for everything. But the biggest problem that we as flat earthers have is verifiability.
Well, Perseids meteor shower. I mean, we can
you're describing what it's made out of and all these other things. But the question is, how do you verify what exactly it's made out of?
Well, it's material. I can't say whether it's silica or iron or whatever, but it's material that burns up before it hits the ground. Therefore, it's not got much mass. It's not like a meteorite that reaches the ground, which has to be a fair size, otherwise it would have all melted. Like, a spaceship, if its re-entry shield fails, it will burn up. It will literally turn to plasma because of the friction.
So if it's totally all burned up, how do you know what it's made out of?
That's what I'm saying. I can't say that meteor is made of iron, silica, stone, or whatever. I don't know. But what you can say is it was something very small, about the size of a grain of sand. But actually, it may be possible, I don't know, to use, what do you call it? Like they use on the sun to get the... oh man, I'm struggling with the words. The absorption
I heard a lot
lines.
about the redshift, but I
No, not
redshift.
It's going nowhere near fast enough for that sort of thing. But I'm talking. When they you split the light from the sun into a rainbow, and you can see the black absorption lines. Do you know about them?
Splitting the sun from a rainbow.
Yeah. You know, if you get a prism, and it makes a rainbow. Yeah. If you split it well enough and you've got the right conditions, you can actually see black lines called, I think they're Fraunhofer lines, something like that. Fraunhofer lines. And every chemical material, every molecule, like for instance helium, hydrogen, and so on, has its own pattern of lines, which actually feeds back to your mentioning about redshift. When you get something moving very fast,
so now you're talking about spectroscopy.
That's it. Yeah. So what I'm saying is, just going back to our meteorites, how do you know what they're made of? What I'm saying is, it's possible, but I don't know that you could take a spectrograph of one of those. Catching one would be a bugger, but maybe that's possible. I don't know. Maybe someone can tell us in the chat if they can tell, or how they tell what meteor showers, what the material is made of, because I don't know.
Yeah,
but they are the remains of the
a lot more flat earthers about different things and say, oh, well, I can't deny that if you can verify it. So then they're going to be forced to be able to apply that to their model. The better you can verify your claims. Does that make sense?
Well, we can verify things like meteor showers come around regular as clockwork. If you pick, I mean, each year I go out, if the weather's okay, to watch the Perseids meteor shower. It happens every year. We know the orbit of the comet that produced it. The Earth passes through that orbit. Therefore, we get some of the dust that was in the tail of that comet strikes the Earth's atmosphere, burns up, and we see it as shooting stars.
Nice explanation.
Some of them are recovered.
It's just not verifiable, and so I don't see how that really.
Sorry,
I don't see how that. All right, go ahead.
Kyle, what is not verifiable?
The facts behind your story, and so exactly what it's made of. Is it actually burning up in the Earth's atmosphere? There's all these different things that just because it's clockwork, just because it's predictable, doesn't really validate the story. It's just
no. But Kyle, the meteorites are recovered and they are tested and they are proven to be not from Earth. They are proven to be from having all the telltale signs of coming through the atmosphere. So that's where it's been verified. And obviously, you say you've not looked into the fission crust. So at this point, with you saying it's not been verified, it appears to me that the fission crust is a big part of the verification process of determining how they've, where they've come from and how they've got here. So it's kind of difficult for you to one minute say I've not looked into the fission crust, and then to say it's not been verified. Because, like I told you earlier, when I looked into how we...
Sorry, forgive me on that. Yeah, to my knowledge, I should say that instead. You're right.
Yeah, no, that's fine. That's fine. So at that point, you should just obviously agree to, at some point, go and look at that and then say, and then make a conclusion from that point.
Kyle, can you see Kyle? Can you see the stream?
I can go see it. Right.
Yeah, make sure you turn the sound off. I've just uploaded a picture of Perseids meteor shower. That it's a stacked image, so it did not all occur at the same exact point, but it shows you the meteors. But as I said, those are little bits of comet tail that no more than the size of sort of grains of sand, because the bigger they are, the more likely they are to make it through the atmosphere. You do occasionally get some which will explode and make fireballs. I've seen one of those once. It's beautiful. Some of them give different colours, slightly different colours as well. But those are meteor showers. The other thing is, as you can see, they're all radiating from, or pretty much, because others could be from, just random meteors. They're pretty much radiating from a point in the middle of the screen. Now that point would be, that's why they're named Perseids or Geminids, whatever, because they appear to be emanating from the constellation of Perseus or Gemini. That's where they get the name. So at that time of year, when we're in that part of our orbit, on that date, we will see the meteor shower like that.
Okay. So tell me about that connection. So you've got a claim, you've got an argument.
Yep.
What is it connected
I'll
to?
tell you the connection. So those meteors are hitting our atmosphere, burning up. They are following a path. That path is calculated, and you can see, and that is the path the comet came in. We know that comets. Look at something like Halley's Comet. It comes around every 76 years, sweeps around the sun, goes back out beyond the planets, and eventually comes back again. Now, this cometary path does that. Therefore, if those bits of dust and sand, whatever they're made of, whatever the exact material is, they're following that path. Therefore, they would have to pass through any dome, any firmament.
Okay, so your claim is that meteors are a counter argument to the firmament because they have to be able to pass through it. Is that right?
Yep.
Okay, good. All right, I can write that on my big board.
Okay, something to look at. Yeah.
I can write that, and so I can definitely look further into that in the future. And
Please do, because
I really love this kind of stuff.
I mean, the good thing is, Kyle, there'll be one of two outcomes to that. Either you look into it properly and decide, you know what, I can't explain it. How would that happen? How would it come through the dome? Or you'll have to come up with some other explanation. Now, obviously, right now, I would say whatever explanation you could come up with, I would believe is wrong. However, if you can come up with an explanation, then we can look at it.
Okay. Yeah, there's quite a few explanations that are out there concerning meteors and meteorites, such as it could be debris from a volcano who knows where.
Okay, just taking that as, I know that's just off the cuff that you just said that, you'd have to explain why it happens every year on the same date, coming from the same direction in the sky.
There's a lot of different things that can be very reliable just within our Earth. I just look at Old Faithful and how Old Faithful, the big water geyser out in Yellowstone, is very, very predictable.
You do know, though, with... Sorry, I interrupted you.
You're fine.
I was going to say, you do know that, yes, Old Faithful has been quite reliable. Other geysers, or geysers, depending how you say it, have failed. And in fact, there's also a problem with people throwing items into it for whatever reason, because they think it's funny, and actually
changing things,
preventing them from, causing them to fail, basically. But yeah, that is pretty reliable. But
there's a lot of different volcanoes all throughout the world that could be shooting off debris, and it's not unheard of to hear of some really crazy volcanoes that can shoot debris like miles and miles and miles away.
Well, you could get dust cloud.
I suggest there,
the stuff that goes very, very high is very, very fine, but it's within the atmosphere and it doesn't burn up like that. But again, you'd have to explain. Let's say you came up. I know, like I said, I want to be fair to you. That just came off the cuff, and maybe when you thought about it, you said, "Nah, forget that. I'll think of something else." That's fine. But using that as an example, you'd have, as I said, you'd have to explain why it's always seen emanating from exactly the same point in the sky, like the centre of that picture I showed you, on exactly the same sort of 2, 3, 4 days every single year.
Okay. And also, if I can pipe in here, if you'd obviously, there will be gathered materials that have been, gathered from around an erupting volcano afterwards, and obviously comparing that kind of material to the material that comes down in the flash of light, like you see in all the videos, and the recovered meteorites. Just compare the two and see what the differences are. Because, like it says, an off the cuff guess like that could be something from a volcano. It's easy enough to verify whether it is or it isn't with something like that. Pardon me. That is something that is easily verifiable. So again, it would need to be a bit more substantial, if you get me.
Okay. Well, I'll just jump in there with a couple more super chats. Mr. David Oliver, he's busy tonight, has super chatted £5 again, saying, "We get bombarded by meteorites all the time. Shooting stars of meteorites. We have sent things to Mars and the Moon and beyond, and no dome was found." David then super chatted again for £5, saying, "What hasn't," because you said about verification, he says, "what hasn't been verified is flat Earth." And lastly, Mr. Mitch Goldstein super chatted $5 US, saying, "Also, Kyle, there is nothing transparent in nature. Nothing. It is physically and chemically impossible."
Nothing transparent in nature. What happened to water? It's water's...
Can you see the bottom of the ocean? Actually,
no. Doesn't mean it's not transparent.
Well, air isn't. Have you ever been to the Grand Canyon?
Absolutely.
And when you look along it, you get a blue tinge, don't you?
Yes.
because the air is not totally transparent.
Yes, and I can see that with faraway mountains. I always talk about that.
Yeah,
Atmospheric opacity is a big deal.
Yeah. So anyway, I jumped in with that because there was those super chats. So where were we with this? We were saying about volcanoes. So okay, I'm not going to hold you to that.
Volcanoes is one thing, but I was just thinking, maybe it's other matter on the other side of the firmament that's smacking into the firmament.
I know, but what's that based on?
It's conjecture. It's just an idea. It's just something else that it could be. Unless those meteors are actually hitting the ground, it could be anything. It's just a random explanation.
Yeah, well,
So
I
it brings
think
us back round to your verifiable point.
Yeah, but to be fair to Kyle,
because I can't get to the other side of the firmament.
To be fair to Kyle, though, Johnny, this whole thing about meteor showers that I just explained about them being the tails of comets and so on, I'd only just put to Kyle, and I think that was new to Kyle. So to expect him to come up with a firm, hard, yep, that's the answer explanation, it's a bit unfair in 5-10 minutes.
No, absolutely. I understand.
So what I would say, Kyle...
No, I never mean to be pushy.
No, you weren't. But I just want to be fair, and I want Kyle to know, it would not be fair to you, Kyle, to expect you to explain that straight away. So please have a think about that. And if you come up with an explanation, either drop me a line or do a video on it. I'd be interested to see what explanation you come up with.
I definitely plan on doing a video and sharing the other information out here that I really haven't even touched on concerning meteors and meteorites.
Okay, so there's one evidence I would put forward against a dome. Another would be, for instance, going back to radar. We bounced radar off of Venus. So
I've heard that claim before, and I wonder exactly how they're able to hear it after with all of the other interference that comes through.
Well, we can still detect the radio from Voyager, and that's now leaving the solar
that just
system.
Doesn't make sense to me. It's like there's all of this interference that comes from the sun that's constantly spitting out all kinds of different radio signals, right?
Yeah, and eventually we won't be able to pick it up. We won't be able to pick up its signal from the background noise. Right now we can. And it takes, I don't know what the time delay is now. It's a horrendous time delay. I'm just going to Google how, bearing in mind the signal's travelling at the speed of light. So I'm just going to Google time for Voyager signals. Right, so I'm not sure. Oh, this was updated September 2017, so it's out of date. Voyager 1 data takes 19 hours to reach Earth. Signals from Voyager 2 about 16 hours. That is at the speed of light. As I said, that's about 2-3 years out of date. So travelling at the speed of light, taking nearly a day to reach us. So Voyager is a long way away. So either Voyager has gone through the dome, or that dome is bloody big.
Yeah. Well, that's the firmament itself is bigger than the Earth.
Yeah, it would have. Well, it have to be, wouldn't it? Because otherwise, it'd be within it.
Yeah. So I would definitely call that big.
Okay, but
you're talking about how high it is and everything. You're talking about Voyager, the probability of Voyager existing with a dome between us or on the other side of that. Is that what you're talking about?
Well, I'm saying when we launched Voyager, we didn't hit any dome. So we're not just talking about things like the space station. We're not even talking about things like the moon. We're not even talking about things like the planets. We're way beyond that.
And so that really comes down to verifiability again, about being able to verify that Voyager is really out there and not just go off of, oh, well, we know it's out there because a scientist said so, and getting into those kind of appeal to authority.
But it's not an appeal to authority. I remember when I was a kid, I saw the film of Voyager. Sorry, I don't know what. I have seen you on video, but I'm not sure of your age, Kyle. But I remember when Voyager was launched. I remember when I was a kid, as it approached, or the Voyagers, as it approached various planets, seeing what now looks piss poor computer graphics, but then was highly advanced demonstrating how it was going to do a slingshot around the planet, then seeing the photographs when they came in. That's been throughout my lifetime. That's one hell of a time to keep some sort of a story up. And of course, there is still an entire team that works with Voyager.
Huh?
Why? I mean, what would be the benefit in that? Why mislead us?
I'm sorry, you cut out. I can.
Sorry. I said, what would be the benefit in maintaining that as some sort of fairy tale story, saying that we've sent out these probes, but we didn't really? Why would they do that? What benefit would it give either to NASA, the US government, scientists whoever? What benefit is there in that as a story?
Money.
I'm sorry, you cut out that time. I missed you.
Money.
So money?
Money, yeah. They've got a huge budget. We got to keep these guys busy doing something, playing cards, while they're monitoring this probe that is supposedly out there. And so there's also kind of this whole thing about feeding into a story. So with the whole moon landing thing, you start a lie, and then you just got to keep feeding into that same lie, and it's a big snowball effect.
Well, Voyager has cost, again, this is just a quick Google, Voyager 1 and 2, $865 million. But Voyager,
It's a lot of money to make.
Well, it's a lot of money. Oh, please excuse me, a lot of money. But that was launched in 1977. You spread that over all that time. It's not so much, and we have learnt so much from it. And actually, what's the US military budget? I can't remember. It's a lot, but some of it isn't published, is it? They have I don't know what they call them, black budgets or whatever.
Yep.
Yeah.
Yep.
So if they really wanted to give this money to someone, they could just put it in one of those black hidden budgets. There you go. There's your money. Why string it along with all this rubbish?
Why string the money along?
No. I mean, why make this story? All you got to do is pay the money, not tell anyone, and say, well, that's classified. That 860 million spent over 40, how many years? 40 odd years. That's classified. You don't need to know what that went on, and it's gone into someone's back pocket. Why to go to all this with buildings and science? Scientists have had their whole careers working on this.
Huh?
Actually, Carl, can I just make a point? Do you not think that saying something like that is actually, I'm trying to think of the right word. It's not very respectful of scientists who are working on that and spent their entire careers working on it.
I just look at it like so many other things out there. I could look at it. I'm not Catholic, but I could point at the Catholic Church and say, there's all these different priests and people following that, and listening to every word that comes from the Pope, and and so I could point to that about that. Does that make sense?
Well, I don't really want to get into religion, but
religion,
yeah. It just seems disrespectful in that we've got photographs from the planets. We had our first, and of course, if they take photos of the planets, and then at a later date, further photos don't match, they're caught out. Mm-hmm. Everything matches.
Oh man, that reminds me of time NASA went and had their picture of Jupiter, and you could see the aurora on Jupiter, and they took a matching photo of Jupiter from forever ago, and they just copy and paste it and say, oh, look, here's Jupiter with the aurora over the top of it. And you went and
so you're saying
look into it.
A particular image was faked or reused?
It was reused.
Okay.
And so I was like, wow, that's so odd that they would do that. And then you actually pull out the magnifying glass and go in and look at the fine print, and they admit, oh yeah, we reused it. And so they are coming out and telling you, And so anyone who looks at the fine print, oh, okay, well, they admitted it, so there's no issue with that. And
Well,
it's kind of a funny story.
But if they're not hiding it, they're not hiding it. It's like when they have images. Do you know? I'm sorry, guys. I struggle for words sometimes. I know what I want to say. Where they use images that are made up of lots of other images, sort of tiled together.
Composite.
Yeah. And people say, see, it's fake. But it isn't. It's no different than using your phone and doing one of those panoramic photos, because that's not one photo, that's several photos stitched together. It doesn't make them fake.
Yeah, the way I explain that one is you take a photo of half a car, that's a real photo. Take a photo of the other half of the car, it's a real photo. Put them both into Photoshop to make one full car picture. That doesn't mean cars don't exist. So it's like when they say that same thing about the photos of Earth. It's like, yeah, some of them are composites, not all of them. Since 2015, the Epic Discover has been taking full photos of Earth that are not composites. But a lot of flat earthers will, spend a lot of time proving composites are composites. And it's like, well, if they've admitted that it's a copy of a previous photo, then they've not really claimed that it's a fresh photo. So it's like the same with the Earth photos. If they claimed it's a composite, no point proving it's a composite. If you want to prove a photo is fake, use one that they've claimed is real.
And we always point to the blue marble, for example, and Richard. I don't want to say Richard Simmons. I can't remember his name.
Robert Simmons.
Robert Simmons,
2012. He explained how and why they use Photoshop. Which, like I say, if you want to have more.
Sorry, Johnny, you're cutting out now, pal.
Me, and then
Johnny, you'll have to repeat that. Johnny, you're.
If anything.
Yeah, sorry, Johnny. Again, we didn't get any of that.
Oh, hold on, man. Yeah, I broke up. Sorry about that. But yeah, so if you're taking a photo of, if you want a detailed photo of a car, and you to take a full photo, say it's a big long truck or something, and you'd have to stand quite far back to take a photo of it. So if you go close and take 10 photos of it, moving along each time, then put it all into Photoshop to make it a full photo, it's still a genuine photo. It's just been edited on a computer, put together.
And actually,
so when Robert Simmons
just with that car photo, it still won't match. Let's say it's a red car. Each of those photos, the reds will look slightly different because you've changed your position. The light's slightly different, so the red will look slightly different. So you can use photo editing software to get rid of those differences.
Yeah, so as he was talking about the Simmons saying it's Photoshop, but it has to be with a blue marble, that's what it was done. To be fair, that's one of the three things that drew me into Flat Earth. Seeing that photo with those double cloud patterns, I'm thinking, well, why would they need to do that? They've obviously faked something there. But when you do look into it and you realise that they've explained why they've done that, they've explained how they've done that, and since 2015, because that was 8 years ago that Robert Simmons said that, but since 2015, NASA have regularly been releasing full non-composite photos of the Earth from the Epic Discover camera. So I always say that to flat earthers as well that bring up that blue marble picture. It's like, okay, but that's an admitted composite. So proving that's got faults isn't proving anything. If you want to prove a photo is fake, because composite doesn't mean fake. If you want to prove one's fake, use one that is released from the Epic camera that is claimed to be a full non-composite photo. It's absolutely just a waste of time trying to disprove composite photos because you will be able to find flaws.
Well, there's actually worse than that, Johnny. I've forgotten who it was. Did a breakdown on a photo and then proved it was fake and it was drawn, but the actual caption. In fact, the file name, I think, was saying it was an artist impression. Yeah. So it was a drawing, and he proved it wasn't a photo, which they never claimed it was.
Yeah.
That happens a lot.
Other times, other times you'll see a photo and it'll say, this was released in 1994 or whatever, and this one was released in 2012. And it'll just be like a different colour. Everything's the same. And it's like, well, that's not been released by NASA. A lot of the time, it's just a false claim or a mistaken claim or just a blatant lie because it's just someone's put two photos of Earth together, changed the colours a bit and claimed that it's been released by NASA. So a lot of the time, you do have to just ask, show me the original source on the NASA site where they've released that second version as an original photo. And most of the time that doesn't happen.
Oh, and with regard to
pretty
what I
much.
was just saying about someone disproving a photo and proving it was an artist's impression, that was JM Truth, as Chris Durham Music Channel and Neilio have put in there. Yeah. Okay, so Kyle, what we got so far is we've got the meteor showers and meteorites. Where would they come from? Because otherwise they've all got to be hanging around within the dome. We've got
Or they could be smacking into it on the other side, but I guess that would be
coming through.
Let's still leave some meteorites. So,
yeah, but the thing is, if they're large enough, they'll land, and they're
the
burning up in the
meteors, like the meteor showers that could be smacking into it and stopping.
But they're not.
They're not hitting the ground, are they? But we see them coming towards us.
What we can
and so your claim is that they're burning up in the atmosphere, and my claim is just they're hitting the firmament.
Yes, but they're not. They're not just. They fade out. You can see them fade out. They're not stopping.
That's kind of what happens.
Yeah, but hold on.
Object.
If they were flying through space and then hit a dome, they'd be invisible. Perhaps you can see an explosion. What we actually got is a long trail. So they're invisible, hit the atmosphere, burn, and fade out as there's nothing left. That's not the same as... That
depends on what's on the other side of the firmament. And so there could be some other material on the other side of the firmament that they're kind of landing in. A lot of people believe that there is water on the other side of the firmament. So it could be splashing down into a big puddle of water, and we're watching that suddenly slow down and fade out.
Are you putting that forward as a possible explanation? I'm not wishing to be rude, Carl, but seriously, that there's something on the other side of it.
I'm just throwing things out there because I know that there's a lot of different people out there who believe there's waters above the firmament. That comes from a lot of different people out there. I can't really verify it. I don't have any evidence to show the waters above the firmament because I've never been to the other side of the firmament, and I don't know anyone who has.
The meteorites are kind of burning up, so if there was water, that burning would need some kind of explanation.
Well,
I mean, obviously, I'm not pushing you for it right now. Just obviously, when you do look into it, just bear in mind all the everything we observe, and obviously bear in mind that we have. I say we scientists. I'm definitely not one of them. Scientists have tested and verified these things and looked into the materials. So, obviously, when it comes to the possibilities you're putting forward, just make sure there is obviously ways to verify what you're presenting. Do you know what I mean? I'm not trying to be horrible.
I understand.
Be awful in any way.
You're making the same claim that I'm making against you guys. It's all about verifiability. And so I can throw out a lot of different mythological explanations for a lot of different things, but the big problem is verifiability. So you've got your explanation of the meteorites, and I've got mine.
What we do
neither of us have a way of verifying
our
that.
explanation. It has been tested and verified.
And what we do...
What did you say that verified exactly what a meteor is made out of? Or
fission crust. It's FI.
Okay, that's a meteorite. That's a meteorite, but not one of the ones that are burning up. And so there's two different kinds of things, and you've got to be able to verify that meteorite is the same thing as a meteor, but a meteorite is one that touches the ground.
Okay, I see your point.
What I would say, though, Kyle...
I understand what you're saying.
What I would say, Kyle, is you think of globe Earth. We've got this... let's keep it vague. We've got this theory that the Earth is a sphere and that it goes around the sun. As to the other planets... we can see with telescopes asteroids going around. We can see comets and calculate their paths and so on. We can see where the path of the comet has been, and when we intersect it, we get meteor showers and so on. What I'm saying is, forget any one of those. The whole thing altogether works as a consistent story. Like, for instance, the seasons work with the fact that we're tilted at 23.4 degrees. The distance, the orbit of the Earth around the Sun, using that as a baseline, the diameter of that orbit, you can measure the parallax of stars if you've got the right equipment, the nearest stars. It all.
Or is this a competition to see who's the better storyteller?
No, what I'm saying is, as a I tried to put that in a friendly way. that all those ideas and facts all work together as a consistent explanation, if you prefer the word consistent. So it's not a case of, well, yeah, okay, I can see how the sun rises, how the sun sets, I can see how the planets orbit, but that doesn't work with comets. Well, it does. They follow orbits that can be calculated based on gravity, which also explains
like a star.
I'm sorry?
It sounds like a star. A lot of the stars in the sky can be calculated and predicted.
What do you mean?
Stars in the sky, about just like the sun, can be very predicted, and so we can predict
to do what?
Their locations. We can predict a lot of different things that's going on in the sky here. We can predict that this star will be in this location at this time based upon different patterns that we've been able to see. We can predict eclipses, for example. There's a lot of different
which obey gravity.
Things and events.
Eclipses depend on the orbits, which depends on gravity. The fact that the planets are spheres is because of gravity collapsing to the.
Someone from with that.
Sorry.
I've never heard that argument before, that eclipses are caused by gravity. That's a new one for me.
Well, eclipses are caused by planets. And planets move in orbits, and those orbits are controlled by gravity. That's what I'm saying. So you can because we can calculate movements of objects based on gravity. And from that, you can predict. You can calculate their path. You can predict when this path crosses in front of that path, and so you can predict an eclipse. In 1982, Kyle, I had the 1982 Yearbook of Astronomy with a foreword written in it by Sir Patrick Moore. In there was a table of meteor showers and so on, but also solar and lunar eclipses. This was 1982. In there was the total solar eclipse, August the, I forgot what the date is, August the whatever, 1999, and the fact that it would be viewable in the UK in the tip of Cornwall. It would be a total eclipse. So that was 17 years before. For 17 years, I waited for that, and in 1999, I went down to Cornwall. And unfortunately, the cloud was too thick to see it properly. However, I saw it as a partial eclipse, but then the cloud cover got too thick, but then it went totally dark. That was written in a book, and I've probably got the book somewhere. I do want to dig it out. But it was 17 years before. It said the day and time to the minute that moon would move in front of the sun, totally eclipsing it, and where you'd have to be to see it.
And can I just jump in there as well? The eclipses, when you have a lot of everyone was able to predict eclipses before heliocentrism, it's not entirely true. I mean, they were able to predict them, but nowhere near with the accuracy we have today. They could predict the next one absolutely fine, but trying to predict multiple, the accuracy just went way off because of the misunderstanding of heliocentrism. So since obviously heliocentrism came in, that's when the accuracy of predictions became much more accurate. Just a quick one.
There's a lot of technology that's come out that's really helped out too. When it comes to predicting things, we can do math to a much bigger degree with a lot of our calculators and other things that really help us out that we can do today.
Yeah, and there's obviously the cycle. You know, the cycle of flat earthers claim that you can predict eclipses based on simply the cycle of the Earth rotating around.
Egyptians a long time ago, they were able to predict eclipses, weren't they?
But not with the accuracy we can today, and not multiple.
They were able to predict quite a few of them, and yeah.
Kyle, can I just confirm? I'm not asking you to dox yourself, but you're in the US, aren't you?
Yes.
Are you able to say which state or town, if you're happy?
Yeah, I'm happy with that. I'm from Utah.
Utah. Okay. No, it's okay. Carry on, guys.
I think I've been Utah, you know. Anyway, I'm going to have to pop off for about 10 or 15 minutes. I'm just going to put my daughter to...
Okay, Johnny. Not a problem. Thank you. I'll leave you sat in there as long as you mute your mic, and then when you come back, you can jump in, okay? Sounds like he's gone already.
Okay.
Yeah.
Yeah, no problem. I did cut off then, but yeah, I'll be back soon.
Okay.
I'll cut my mic off.
Okay, cheers. Yeah, Kyle, I was just trying to see about, looking at Wikipedia, list of solar eclipses in the 21st century. This is on Wikipedia, and the last one it's showing is September the 4th, the year 2100 at 8:49 and 20 seconds. It gives the location 10.5 degrees south, 39.0 degrees east. Central Africa, Madagascar, and partial eclipse in Africa and Antarctica. Now, I'm assuming that neither you nor I will be alive to witness that one, but that's the accuracy we're talking about. That's 80 years away.
The Mayans, and they built their calendar, and the Mayans were flat earthers, and the Mayans were really, really good at predicting different celestial phenomenon like well in advance. I think I was reading an article recently about how they were even more accurate than with their calendar than our calendar, the current calendar that we use today. Their calendar was more accurate than our calendar.
Well, I've not read that.
I suppose it's only fair that with you on that.
By all means, share a link.
It was from the museum, the Canadian Museum of Natural History.
Okay, well, by all means, drop a link to me, and I guess that'd be something to have a look at it. Oh, actually, I've just seen a guy called Mark Tin in the side chat says, I remember him standing under the clouds in Cornwall. I saw a 98% eclipse from home. Yeah, I took my daughter down to Cornwall to see that eclipse. And as I said, I was waiting and looking forward to it for 17 years because obviously I wouldn't have to travel abroad to see it. I missed one that I could have seen in Central Europe at some point, but I was determined to see that one, and I was there for it. As Johnny was saying, and as this... Actually, I wonder how many eclipses it's listing. It's listing total and partial and annular eclipses. Oh, during the 21st century, there'll be 224 solar eclipses, 77 partial, 72 annular, 68 will be total, and 7 will be hybrids in between total and annular. So that's pretty astonishing. Oh dear, I'm going to have to move Johnny out. Johnny? Yeah, I'm going to have to move Johnny out because of the background noise. Perhaps Colon, you can let Johnny know when he comes back that that's why I did it, and I'll bring him back in a minute. So all those eclipses, all predicted down to the second.
Huh?
So, I mean, that shows you the capability. So how we got onto this was saying that it's all a story that hangs together. And you jumped on the word story, and then I revised and said it's an explanation. So all these things. So the movement of the planets and the moons are all calculated using our knowledge of gravity. Using those calculations, we can make those predictions, and those predictions, in this case, span the next 80 years and should be correct to within a second.
I've got to find that piece about the Mayan calendar. I'm still looking for it here.
Well, listen, drop it for me some other time if you wish.
Okay, sure. No problem.
Because I would have to say I'm doubtful, but I can't argue against it because I have no knowledge of it, okay? So drop me a link sometime, we can discuss it, that's fine. But that's what globe Earth theory is able to do. What can flat Earth theory do? What predictions can it make?
That was one of, as I recall, Professor Dave Explains. He did one of the Big 10 challenges for, one of them was make a prediction. And there are quite a few predictions that the flat Earth theory is able to predict. And so one of the ones that I personally did in my video series here was I predicted that the reason we see boats appear to sink on the horizon is because of atmospheric refraction, not because of the shape of the Earth. So that's prediction number 1 in my video series.
Right. Well, we know... I'd like to know the explanation of how refraction makes them disappear from the bottom and the bottom only. And
it starts from the bottom up.
Actually, before we get into that then, Carl, because it's a bit of a change of direction in our discussion.
Right.
And that's
well,
okay.
you're talking about predictions, and that was just a prediction.
And I'm cool. I'm happy to talk about that. But I just thought I'll read the last couple of super chats I got from Hugh Jars. Has super chatted $5 Australian saying, Kyle, in a nutshell, lots of beliefs and assumptions based on those beliefs, but zero evidence by his own admission. The guy isn't a scientist. I know that you haven't claimed to be. And David Oliver has super chatted yet again, £5. Thank you, David. You're so generous. Super chatted saying, Mr. Sensible, apparently most asteroids are made up of gravel-like material. Solid ones are rarer. Well, there you go. I wasn't aware of that. So hopefully I've learned something new. Okay, so we talk about predictions, because I'm not trying to hide from what you're saying. We talk about predictions and boats disappearing from the bottom up. Oh, and actually, just before we go in that, Kyle, you're saying about the Mayans and their calendars.
Yes.
Of course, as Chris Durham Music Channel has said, the Mayans actually predicted the end that the end of the Earth would happen in 2012. They didn't get that right, did they?
No, they didn't get that right.
No, okay, fair enoh. Yeah, so let's go back to this business predictions, ships, bottom of ships.
Okay. I just gotta say this about the Mayans stuff.
Yeah.
Okay. The Mayans, people, they inserted that after. I don't recall the Mayans ever saying that Earth would end at 2012. That was just the end of their calendar. And so, it's reaching the end of the calendar. Oh, that must be the end of the world.
I think I've heard that as well.
Source on that.
I think I've heard that as well, and it's probably a bunch of end of the Earth is jumping onto it as an excuse. Yeah.
People can be kind of dramatic about that.
Yeah. So yes, atmospheric refraction and ships disappearing bottom up.
Yeah. So we just talked about the atmospheric gradient and about how it's got the most pressure lower it is to the ground, right?
Yes. Yeah,
so that's where the most refraction is going to be. Right?
Yeah. Well, it's not just pressure; it's temperature, and no doubt moisture as well. But yeah, temperature.
We agree that light gets bent downward, and so because it's closer to the ground, it ends up not reaching us as much. It ends up getting more refracted than the light that is up higher.
Okay.
I go into much more detail on it, and I know there's a lot of other people who really go into it as well. But when I know Rob Skiba here, he's done a bunch of videos on the matter where you can put a lens and watch the sun go down when it's not really going down. It just appears to be going down. And the bottom of the sun is what touches it first. And so it's the same thing as with the sun as it is with a boat on the horizon. They're going down for the same reason. It's all refraction. And the sun, it appears from the bottom. It starts sinking at the bottom first. Does that make sense?
Yeah, I'm just pulling up a photo for you to have a look at in just a second. Right, I'll just try and enlarge it. Famous photo. It should take about 30 seconds for it to come through to you. I'll tell you what it is anyway. It's the very famous photo of a clipper ship with 3 masts with its sails showing above the horizon line, and everything else disappeared. Now, if that is due to refraction and a gradient, that gradient is showing you everything that's above a certain height and nothing below a certain point. If it was just down to a gradient, then it would get more and more squished. I could understand that more, but this isn't. Vertically, there's barely any distortion. You've got a hard line, sort of a part way up that ship. Nothing at all can be seen below it. Everything above can be seen above it, and no matter how powerful a camera or telescope or whatever you had, you won't see more than above that line that's there. Can you see the image yet?
Yes, I can see it.
Okay.
And I'm so glad you brought this up because I've been thinking about this one since our last conversation.
Okay.
And I I'm really, really glad you brought this up. Okay, so we understand that there's a little bit of distortion here going on because of the heat haze, right? And that's why we see the wiggle on the mast.
But there is some
especially
slight distortion. Yes,
there's a little bit.
Yeah,
but
very little.
Distortion isn't what proves like atmospheric refraction can happen without distortion. You look through glass of water, for example. There can be sometimes that can warp things, yes. But it is possible to. I'm trying to think of a better example of watching something get refracted without being distorted. It just looks like it's out of place, and that's it. And
like a straw in a glass of a straw in a glass of water. Yeah.
And so it doesn't have to be all wiggly, and it doesn't have to be all fuzzy. You can see it very, very crisp. So does that make sense? It doesn't have to be fuzzy in order to be refracted.
Yes, but
that's my big argument.
In that case, in the case of the straw going into a glass of water, the reason for the refraction, where the straw appears to be almost two straws not joined together, is because you've got a massive difference in density between the straw that's in the air and the part of the straw that's in the water. In this case, that entire ship is in the, apart from a bit, I'm not talking about the bottom of the hull, I'm talking about the hull and the bottom part of the mast and the bottom part of the sails, all of that is in the air. There is so the difference between the air at the top of those masts and the air at the bottom of the hull just above the waterline is virtually zero.
Yes.
So how can it distort, like your example of a straw in a glass, to the extent that you see nothing, absolutely nothing below that certain line?
It's just what I told you about the sun here. When you watch the sun go down, you're being able to watch it go down without distortion. I guess you need a picture here from the Rob Skiba video of him doing the holding up a lens and showing the demonstration of the sun going down when placed in front of a lens. It's just being pulled backwards.
I have seen his video, and the Fresno lens.
It's not distorting the sun. But it's still going to sync.
Yes, but that lens has a distinct center to it, doesn't it? If you see what I mean. I'm not sure exact pattern of the lens, but it's almost like circles surrounding the center of the lens. I'm going to find it very hard to explain.
He started doing the whole lens thing because he watched the professor at Notre Dame University. He did the lens and said this atmosphere is acting like a lens. Or that was
atmosphere can act a bit like a lens. That's refraction. A lens does refract light, which is why some days the horizon can appear further away than other days. Because
that's a big claim. Yes.
Yeah, but if that is flat, there is something physically hiding the bottom of that ship that was on that image.
Yes. Well, the physically hiding thing, that's refraction. It's the light is not reaching you. It's being refracted away before it can get to you. So
but if it was, it's got to be. If it was refracted, but I could understand that. But then the rest of the ship would be refracted to a greater or lesser extent. But apart from that little wibble halfway up the mast, it's not. You've got virtually zero visible refraction until you reach a certain point, and then you've got 100%.
So I can answer that why.
Okay, go ahead.
Please do.
Sorry, because so the whole of the ship would be refracted up, and you asked why. Because why? Because you've got to think, you're assuming that the Earth is flat. So at the end of the day, that boat is just on top of the water, further away. So if any refraction's going on, why would it be happening in between the visible ship and the observer? If the refraction was causing the water to lift in front of the ship, how is that
how is that physically possible? It's the refraction is being, well, obviously the light's refracted down, which lifts an image up. So how is the light being refracted down in front of the ship from the observer's perspective? Do you know what I mean?
Understand how light gets refracted downward?
No, I understand all that, but how is it in that picture that's on the screen? How is it being how is the water being refracted up, but not the ship? When the ship is still in clear view. Well, I say clear view. You can see that the ship is refracted because of the wavy lines, but
The water that you see is a lot closer to you than the ship is. Seeing the bottom of the ship, and so the water that's closer to you isn't being refracted as much as the water that is farther away from you.
Okay,
so the
but
water
ship's
that
further away. So
water that is further away from you is being refracted away, so you can't see that. In other
so
images,
some of it's
you
being
can.
refracted down, some of it's being refracted up. Is that what you're saying?
I don't recall saying that.
Well, no, but
That definitely happens.
Okay. You said that the
There's
water
refraction.
further away is being refracted higher than the water closer. So if the ship is even further still,
Or refraction. It's being
why
refracted
is that not
more.
being refracted even higher still?
So you're talking about being refracted up. Are you talking about being refracted higher as it's being refracted upward, or are you talking about
just 1 second. I'm going to let you two carry on for a minute. I've just got to step away from the mic for a moment, so please carry on. I'll be back in a minute.
Okay.
No problem. No, I'm going off what you said. So you said that the reason that because I asked you, why is the water being refracted, but not the ship? And you said because the water further away. Oh yeah, obviously the ship is being refracted. Okay, we're in some kind of agreement there because the lines on the masts are wavy lines.
Heat haze is a kind of refraction, but I'm not talking about just heat haze. And
no, absolutely.
Now, what you can do, and this is something very verifiable that we flat earthers absolutely love, is basing our claims off of observations as often as we possibly can. And so this is one of the biggest things that we can go out and verify. And so we have a lot of different flat earthers who go out and test how far you can see in different atmospheric conditions. And so Red Pill Philosophy, he's one of the, or he just barely made honorable mention. On the Flat Earth News, he was submitted as a person who was going to make the top 10 most influential flat earthers, but then he didn't make it because he didn't consider himself a flat earther. And so for that, he got put on honorable mention. Anyways, what he did was he went out and took a bunch of videos of different lighthouses in different atmospheric conditions. And so the whole idea is we're trying to get an image really far away with the least amount of refraction going on. And so the big thing is we're checking, so what kind of conditions out there are things that are causing large amounts of refraction? Number one is the heat and humidity. And so the ideal circumstances to be able to see really far away out past a curve are going to be cold temperatures that are cold and dry is what you're looking for. And so he went and observed a bunch of different instances and saw that we could see more when there's less refraction.
No, okay. So I think the misunderstanding there is that obviously different weather conditions produce different effects of refraction. So it's not that cold equals not less refraction and warm equals more refraction. I mean, it might be the case to an extent, but there's still obviously going to be some
infinitely far on a cold day. No one claims that.
No, absolutely.
There's still refraction going on. There's much less refraction.
Yeah. Now, this is a big point I always bring up. Obviously, there is a limit. So there are stupid globers as well. Don't get me wrong. That will say, "Why can't I see the Eiffel Tower from New York?" And obviously, the answer is because you can't see forever through the atmosphere, even if the Earth was flat. So the atmosphere does become too thick to see through. But the point is, a very important point to notice there is that the horizon is much closer than that limit. So the mere fact that we can see a clearly defined horizon, as far as I've worked out. No. The horizon distance doesn't change. The amount of refraction changes, but you can measure the distance to the horizon from the perspective of the average eye height, and it's 3 miles in every direction,
Guys-
roughly, around about 3
guys,
miles.
Guys, we'll come back to that in just a second, because there's two things I want to do. I want to read out a super chat from David Oliver again. Thank you, David, for £5. Going back to the calendars, the Mayans. Our calendar ends every year because every year I have to buy a new one. Thanks for that, David. And what I just want to do is I'm just going to play my patron reel. With massive thanks to all my patrons, including new patrons Brian Ramsey, ex-Penguin95, Sharkwork, Stephen York, Uwe Closer, Wee Scott's Dog, Marconius and Jason Ooting, and my newest patrons, Kevin Seidel and Doc Brew. Thank you all so very much. And we're back again. So we were just talking about horizons and so on. Johnny was saying about the horizon. Well, you've got a physical geometric horizon which you can calculate, but it is affected by the atmosphere. That was the whole thing with the black swan crap. The fact that they said, you can see the horizons beyond these platforms, they are 9 miles away or whatever it was, therefore the Earth...
Yeah, and then they counted a cloud bank back as a horizon,
saying that the Earth couldn't be the size...
Sorry.
It's okay, it couldn't be the size claimed, but then plenty of other photos showed the horizon line, the apparent horizon line, in front. So basically...
There's two different horizon lines there.
Well... One is what you see is the apparent horizon line. There is if you had no atmosphere, that horizon line would appear exactly the same distance, no matter what time of day, no matter what time of year. It would always be exactly the same distance. It would never, ever, ever move or change. The reason it apparently changes is because of changes in refraction, and so you're seeing slightly further or slightly not so far because the light is being bent. But what you're not going to see is half a ship like that.
Why not?
Why not?
Why not?
Because
Why are you saying you
being
can't see half the
refracted up
ship?
in front?
Sorry, Johnny, carry on.
How would, because it's like you're saying, why wouldn't the ship be covered? It's like, why wouldn't the ship be refracted up? Sorry, not the ship be refracted up. The light's refracted down, the ship, the image of the ship's brought up. I always use the word refracted wrong, I do apologise. But why is the image of the ship brought up? Why is the image of the ship not brought up, but the water between the ship and the observer is brought up if you're claiming it's refraction that's causing the water to obstruct the ship? If the refraction was causing that to happen, the ship would also be lifted up.
I think there's a huge dividing line right here. And that's this whole battlegrounds with how far you can see. And so I haven't seen any globe earthers address why we're able to see so far and there is the least amount of refraction going on.
So far, like what? Can you give us an example?
I'm going to send you a picture in general chat. Is that okay?
Okay, yeah, please
not
do.
Not the one I've already done. I'm going to send you a picture of 3 different shots of Chicago on different days, showing different effects of refraction. Now, the top, I'm going to send that straight away.
Okay.
Let me know when you can see that. Because it does show different stages of refraction, and you can tell which days are clearer and which have got more refraction and less refraction. And as far as this shows, on the days where there's clearly more refraction,
right,
you see
I'm opening
more...
it now, and then I will get it onto the screen. Just give me 1 second. And then, of course, it's going to take about 30 seconds before you guys can see it. Let me just resize.
And obviously another one, Kyle, is the... it's the time of day as well. Because obviously dusk and dawn are when the refraction is obviously an effect as well. So if he's been out first thing in the morning on a clear, calm, high visibility day, it's going to be different than if he took 3 shots, say 1 at 7 in the morning, 1 at 11 in the morning, 1 at like 2 in the afternoon, and then 1 later on at night. Because what you'll see is if the weather conditions stay similar, you'll see an increase and a decrease in the amount of it's refracted, if that makes sense. So like middle of the day, you'll see less refraction, and earlier in the day, you'll see more. So
The
it's like
image
picture
the image
I've
is up
shown.
on the stream now, so you can see it.
Yeah,
Carl.
so the top one obviously is the clearest, you see the least amount. The bottom one, well, the middle one, sorry, is obviously you could tell with the red sky, see the dawn, dusk, so you see a little more. And the bottom one, obviously a hell of a lot of refraction going on. The whole of Chicago looks completely upside down.
Yeah.
So it does show that the refraction is causing an effect with regards to what's behind the water. It's the refraction is a cause. It's difficult for me to explain in all fairness because I'm not scientific. I've just researched it and understood what I've been told. So the refraction's happening at the horizon. So you've got a slight amount above the horizon, which is kind of in dispute, if you will. I'm not sure what the word to put it as. But those
I love your
pictures
three
there, it's
pictures.
like-
They finally showed up for me here. Yeah, the three pictures, and so we've got the three instances. Which one do you think has the least amount of refraction compared to the most amount of refraction?
The top one has the least.
The
the
top
bottom
one
one
is
has
the
the
least
most.
amount of refraction. Okay.
Yeah, because obviously it seems the clearest. If you look at like the time of day that it's obviously taken at, and the visibility, it's like you've got the middle one. Obviously, if you just take the top one and the middle one because they're similar pictures, the bottom one is a clear refraction there. It's circadian mirage,
Okay. Time of
completely
day.
upside down.
So I'm looking at the top one right now, and it seems to be the one that has the most atmosphere in it. It's the whitest one. So you can see a lot of that light being refracted. That looks like it's the picture. It looks like it's noon, middle of the day. While the one in the middle there, that one looks like it's right there either in the morning or in the evening.
Exactly, yeah.
So
Absolutely.
the temperatures have cooled down at that time, and so with the cooler temperatures, ideally I would think that would be the cooler temperatures, the least amount of refraction.
I think that's a misunderstanding there because during dawn and dusk is when refraction is at its height. That's when it's at its most refractive of
Dawn and dusk is when there's the most refraction, when it's the coolest time of the day.
It
What you're
was, it
saying.
obviously depends on time of the year. It could have been winter when these pictures were taken. I've not got the specific dates I could go
Okay,
to.
well,
'cause it's
even in the
from-
winter, it's dawn and dusk are going to be the coolest times of the day. So you're telling me that there's going to be the least amount of refraction during the coolest times of the day.
Do you know what I was thinking? I'm wondering, if we assumed a flat Earth, okay, there would still be refraction because you've got a temperature gradient in the atmosphere, but it would be very different. The reason we get so much refraction is if you imagine a long curved line, we're what's the word?
I'm thinking of that
We're
laser
crossing-
video you just barely did. You just did G Marble's laser video.
we're crossing the boundaries from one temperature to another. If you're stood pretty much at sea level looking across the sea and it was a flat Earth, you'd be looking through the temperature, let's say 6 foot above the surface of the water. There'd be variations, but it wouldn't be much between here and there. But because it's a globe Earth and a curve, you would be looking, because the object perhaps is hidden or partially hidden, you're looking in a straight line, but your point of view is veering away from the surface, getting higher and higher towards, let's say, the tops of the buildings, and you're looking through different heights of air, different parts of the gradient. That's why you see refraction. On a flat Earth, it would be very different.
Sorry, that was
Does
really
the-
jumbled.
does
I
the-
had a hard time understanding.
Yeah,
what you were saying.
I'm trying. It is hard for me to
Is the,
explain
is,
that.
the, is the angle of the sun rays not a factor in it as well? Because obviously, while the dawn and dusk, the angle of the light coming through is at a completely different angle to like middle of the day when it's high above. I'm not sure. Obviously, that's why I asked. Does it not cause a? Is that not a factor? Something to factor in?
I don't know. I'm going to see if I can explain this a little better. It'll be a bit delayed, Kyle. 1 second. Let me just. I'm going to use what I've got to hand. So I've got a picture frame and a cup. Okay. Let me turn this photo off. There we go. Right. So, if this is our spherical Earth, if I'm stood here, you're going to see this in a while. If I'm stood here, sorry, I stood here looking at something over there, then the straight line. Let's get a ruler. The straight line is like that. So my point of view is getting higher and higher, further and further away from the surface. The air is a different density and different temperature, so that's where you get refraction coming in. But if I change for a flat Earth and I'm at one end looking at something at the other, then
I can see you moving around, but
you'll see it in a minute.
You'll see it in a minute. Picture down.
I haven't put. I didn't transition it. Let me start again. Right, sorry, one sec. My bad. Right, I'll start again.
Okay.
So, forget scale, because scale is not good on this. But there's the Earth. Okay, I'm stood where this handle is. Okay.
The three pictures of the Chicago skyline are still
going in a minute,
It'll come up. It'll come up. In fact, it should be just coming up now. So we've got this cup. Where the handle is where I'm stood, and I'm looking at an object sort of over here somewhere. So if we take the straight line view, I'm looking at a tangent across the surface, looking higher and higher away from the surface. So my point of view, following that line of that ruler, is getting higher, further away from the surface. Not much, because this scale is crap, but you know what I mean. So I'm looking into air of a different density. So because we've got changes of density and temperature, you're going to get quite a bit of refraction. So if I go to my flat Earth equivalent with this picture frame, I'm stood at one end and I'm looking at something towards the other end, and I'm this tall. I'm pretty much looking the same height above the surface. So there'll be very little change in air density and temperature. There will be some, but because of it varies all over the place, but nowhere near as much as looking from one height through to another height. Do you get my point? So what I'm saying is, on flat Earth, density would work. Refraction would work differently. I don't know all the ins and outs and how it would work, but it would be different, because you're not looking from a low point curving away from. Sorry, there's your curved surface. Not looking like that, further and further away from the surface. Do you see what I'm saying?
I think you're trying to say that atmosphere, we're looking at like a parallel line with the ground.
If it was a flat Earth, you would be, yes.
And so if it's a flat Earth, we're going to be looking through an atmosphere at a parallel line.
Yes. So although there may be variations, there wouldn't be a lot of variation.
If we're looking down, then there would be more variation.
Well, it's not down. It's you'd be looking. If I'm stood here looking directly that way, as the surface curves away from me, in effect, my point of view is getting higher. I'd be looking through air that is higher and higher, further and further away from the surface, with a spherical Earth. So what I'm saying is,
start off being dense because it's closer to you, but then the farther
not closer to me,
closer to the
closer to the ground. But even then, it can be variations, and air can be slightly denser further up, depending on atmospheric conditions. But what I'm saying is, you start off at pretty much ground level, and you're looking higher and higher as it gets further and further away. With a sphere, but with a flat Earth, I'm looking straight ahead. It will be the same height above the ground. So what I'm saying is, refraction and how it works on a flat Earth would be very different than on the globe Earth. I don't know exactly how, and it would be interesting to have that calculated. I've forgotten who did the advanced refraction thing, where you actually got a photo and you change the parameters and the image stretches.
It's on Mick West Metabon.
Decimal Z would be a person I would love to talk to about this, because he's the one who made a really great AutoCAD video was able to simulate refraction. And he's got a great video on that, about what refraction looks like on the flat Earth and how it can cause the sun to appear to set, just like Rob Skiba's example.
But actually, I mean,
if he can do that with a flat Earth, I can imagine he would be able to do that with a globe Earth, and so you could have an example. Is what I'm trying to say.
Well, it'd be very interesting to see how refraction would make the sun set, because looking at Johnny's photos of the Chicago skyline, it's very different every day. And assuming you've not got clouds blocking the sun, you've got clear skies, that sun will go down, and at first the very bottom of it, then a bit more, and then half of it, then 3/4, and then all of it. I know you get a bit distortion, it appears to flatten and so on, but yeah, if you've
It
got,
appears to sink, yes.
well, it does sink.
Well, I understand that.
Otherwise,
different
under certain
perspectives.
conditions, the sun would set minutes late or minutes early, but it doesn't.
Okay. And so there's variances, and that can cause the sun to change its shape, that are apparent shape. Sometimes it'll look more ovally when it starts to set.
Yes.
That can happen.
Yes, definitely. But it still sets at 5 o'clock or whatever the predicted time is.
Yes. And while there are many variances in the air, there's also a lot of consistencies in the air as well that need to be taken into account. And so there's two things that cause the sun to set. And so number one is going to be all Rob Skiba the only thing he ever talks about is the atmosphere and how the atmospheric refraction can cause it to set. But there's this other whole thing about the firmament and about how the firmament is able to refract the light, and that ends up sending the light into different places on the ground. And that can also, and the firmament is a solid fixed object that that's not continually changing all the time. We can look through the firmament and we're seeing a lot of things that don't look distorted.
Kyle, I'd still fail to see how refraction would make the sun set. It might make it
The bottom up.
No, it might make it. Well, okay. I'll tell you what refraction does. When we see the sun set, it's actually physically set, geometrically set a little while before, a couple minutes before. It rises a couple minutes after it apparently rises. But it still rises, it still sets. If the Earth was flat, then you would still get light from the sun. You know? How would you get night time? Because the sun is somewhere else across the flat Earth, but there's nothing blocking it from you seeing it.
And all of the light is being refracted downward. None of it can reach you. And if no light can reach you, are you going to be in the light or are you going to be in the dark?
No light can reach you.
If no light can reach you because it's being refracted away from you, are you going to be in the light or in the dark?
But let's say you're stood in a place and you've got perfectly clear skies, whatever amount of refraction, you've got clear skies, okay, no clouds. That sun sets, okay. Sometime later, you can see stars as it's darker. You can see stars right down to the horizon line. If it's really clear, they're not being refracted so you can't see them, and yet.
Why do you think that?
Sorry, why do I think that? Because you can see.
Don't you believe that stars are being refracted? Like, isn't that why you believe stars twinkle? Is because of refraction?
Yeah, but that's something.
Okay, so you do believe stars are refracted?
Hold on, you're trying to put words into my mouth there. Yes, stars.
I asked you a question. That's not putting any words into your mouth. That's a question.
Yes, stars twinkle, but that is. They are twinkling. They're not being moved up or down. Okay, they're in a position, but the actual image is twinkling. But the sun doesn't get further and further away and start twinkling. The bottom half of it disappears, and the sun is quite bright because it gives us all our daylight. And yet a star, which gives us, you can barely see, can be just above the horizon, as clear as day. It might twinkle, but it's still just above the horizon. It's not disappearing. So how is it that this refraction can hide the sun, but it can't hide the tiny point of light from a faint star?
Same. So, okay. That if refraction can affect the sun, why isn't it affecting the star? You think the refraction could be able to hit the sun but not the star? Okay, no, you don't believe that. So I'm all a little bit confused to this whole thing that you're talking about here.
Okay, what we got?
As far as I am aware, the same refraction is affecting the stars just like it's refracting the sun. The stars appear to rise and set just like the sun does.
On an exact period that coincides with the rotation of the Earth. And someone's just pointed out in chat, planets don't twinkle.
Don't?
No.
Oh,
They're that little bit brighter and nearer, and they don't
so
twinkle.
all of the twinkling is done from solar wind, like all that solar wind.
Well,
is
no,
not
it's
supposed
nothing to
to
do
be
with solar.
significant enough
The
to
twinkling is to do with variations, looking along a road. You know, you see in the summer you see heat devils, and the image is moving constantly. If you're looking at something right
Okay,
down at the so it's
Our
that
atmosphere is
that
the
sort
thing
of
that-
variation in the atmosphere. Like look,
variation
I tell you,
in
I can
our
think of a
atmosphere
good example, Kyle. If you had a glass of water and suddenly dumped in a load of salt, you know, the water looks funny. I'm not talking about the actual bits of salt you might see for a little while, but the dense, as it's mixing, the water is denser and less dense until it's properly mixed. You get those variations. That would be a rough equivalent
instances.
to the atmosphere, those little variations in the atmosphere causing the faint light from the stars to twinkle. The planets are brighter, so it doesn't have that effect on them. The sun is brighter still, and you don't see any twinkling or distortion at all from that. Not that sort of movement. Yes, you get...
So the stars are too small.
No, they're too faint.
Okay, the stars are too faint. And so you're saying that the planets can not be affected by the refraction because they're so bright, but stars are affected by refraction because they are so faint.
Well, we're talking about the twinkling aspect of refraction.
Okay.
Oh, and Hugh Jars has just said the moon doesn't twinkle either. Well, I mean, that's...
Okay. So I'm trying to retrace. I like to visualize the board in my mind here. It's often called a mind map, and I think that's for a good reason here. So, and to find out where we came from and exactly where we're at right now and how it's all connected together. And so, refraction of stars. You're saying that a star would not be able to set while the sun would. From refraction, it's all still very muddy to me.
Right, you're saying that the sun sets because of refraction.
Yes.
Okay. I'm saying the sun sets because it's going behind the horizon. We can agree that yeah, okay. That's
so
our
that's
views.
another instance where we both observe the same thing, but we have different explanations for it.
Right.
And so your explanation doesn't really take a whole lot of like there is some atmospheric refraction in your explanation. Which is why sometimes the sun and the moon can get warped as they set.
But
there's
it was
very
still
little refraction in your
physically
explanation.
set behind the horizon. Yes.
Yeah.
The stars are a lot fainter, and they will set behind the physical horizon, but you don't see them distort. I mean, they're very small, obviously, to the naked eye and whatever, but you don't see them sort of getting cut. Actually, I want to step back a bit. What I was saying about the sun setting behind the horizon, you're saying it's refraction. Again, we're back to that point about the boat, the bottom half of the boat. How would refraction 100% hide the bottom half of the sun and 100% not hide the top half of the sun? Even if it squished it a bit.
I really don't understand what it is you don't understand, because it's very replicatable. We can replicate that. We can do that in a fish tank if we wanted to. I've seen those instances of shining a laser through a fish tank, and you can watch the laser bend down and hit the bottom of the fish tank. And so if that can happen, we could put a picture on the other end of the fish tank and look through it, and we could see the bottom half of the fish tank, the picture, not being visible, while the other part is, the top half of it, because the light is getting bent downward. And I don't know, I just keep pointing back to that Rob Skiba video of the sun appearing to set, and it's starting to set, and the sun can go down below his apparent horizon, which is the table. And someone else did it. I think it was David Weiss from Deep in the Rabbit Hole. He showed a candle flame, and he put a candle flame back behind a lens, and he just moved it backward, keeping it parallel with the table. But that candle flame appeared to be sinking.
Okay.
At an even
well,
rate.
Here's a thought then, and actually I will just read out a super chat. Hugh Jars super chatted $5 Australian. Ask him to explain the existence of the South Celestial Pole. See chat for my link to my video of it. I will come back to that if we have time, Hugh. But you're talking about the sun apparently setting due to refraction, Kyle. Whatever the distance and height of the sun, would you agree the sun is a fair distance above the Earth?
Yeah, it's
okay.
Definitely.
So can you explain to me how, well, there's two things. One, how it can shine on the underside of clouds at dusk or dawn, and how and why it lights up the top of mountains at dawn and then goes downwards, but at the end of the day, the top of the mountain is still lit, whereas the bottom isn't.
I actually address each of those things in my videos, and I know Rob Skiba, he specifically looked at the underside of clouds, and he replicated that in one of his things. There's a reason why he's number 2 on the list of most influential flat earthers right now. It's because he's able to do these really amazing experiments and point out exactly how that's possible.
Well, he's the main reason I'm
So,
no longer
just
a flat
like you
earther.
did, though,
just to throw that in there. No, seriously, 100%.
Slow or faster? I don't know. So, yeah, there's just like he did the sun sinking. He did the same thing, and he did a little artificial cloud. And he's like, okay, let's watch the light after the sun sinks and see if it can light up the bottom of this cloud, even though it's parallel with the cloud. And there you go. He was able to do it.
Well,
pretty cool.
I have seen a video taken from an aircraft at dusk, looking, forward but downwards at an angle at the clouds, and the sun appears to be below. It's shining upwards.
Okay.
Because, and actually thinking about it, with the, you said about the clouds. So the light would have to be refracted in some way that having come downwards, it turns and goes upwards.
Yeah? It happens sometimes, yes. Just thinking about my... I've got a video on that one on Light on the Mountaintops, and that one specifically addresses that. I think you've even addressed that video in the past, and you looked at some faraway mountains and say, oh, okay, well, there's some mountains over there that are also being lit, or I don't remember exactly how.
I sort of half remember that as well.
Yeah, it's kind of foggy there, but I remember you addressing something like that, and I wish I could remember all that better.
Yeah, okay. Well, perhaps I've had another super chat from David Oliver. David Oliver, thank you, sir, for £5, saying, Kyle Adams, please explain 2 points of star rotation. So that's two super chatters have asked about that. Have you got any explanation of why we see the stars rotate roughly around Polaris in the north, but also around the area of Sigma Octantis in the south? How can you have 2 points of stellar rotation unless you have a sphere?
I've got multiple videos on that one on my channel here.
Yeah, but okay. And actually, can one of the mods please post a link to Kyle's channel if someone could dig it out? It's the flat. It's under your name, isn't it, Kyle Adams?
Yeah.
Yeah. So if someone can find that, because So it's a
playlist on there. The Flat Earth Institute of Science is a playlist on the channel.
Okay. So that people can look at your channel. So yeah, I want to give you a shout out. You've come on here. We've been having a nice chat. You certainly deserve a shout out to your channel. I'm not sure what sort of comments you'll get, but there you go.
That's all right. Okay. I welcome them.
Okay. So we were talking about 2 points. How do you
If
explain?
anyone would like to debate them, because I know people like to do that. If anyone would like to debate them, I've got a whole other board here that I'm introducing, which is my debate thing. And so that you can talk about each of those and just connect it to either support for a globe or support for a flat Earth. And you can make your arguments there, and you can argue all about my videos that I've done there.
Okay. So, you've addressed it in your video or videos, but can you sort of tell us now?
Summarize?
Give us an explanation of how you would have 2 points of stellar rotation.
The simplest answer is just refraction. So,
Refraction.
Refraction is what causes it. And so there's a couple of different video examples there of watching what happens when you take a dome and you look through the bottom side of it at some straight lines, and how they can also appear to rotate. And you can get 2 points of rotation when looking at these parallel lines they're moving on a dome. It's kind of a wild example. I wonder if I can grab a picture so you can have a visual of what I'm talking about, because it's just really cool to look at.
Well, I can't see how refraction can explain this one, because we, assuming clear skies, you can see, looking north towards Polaris, you can see those stars proceed round the point roughly at Polaris. Well, let's say Polaris, it's not exact, but rotating around Polaris at 15 degrees per hour, i.e. the rate the Earth is turning. You go further and further south and start looking south, and eventually you will see, once you get beyond the equator, you'll see the area around Sigma Octanis rotating in the opposite direction in circles around that. So it's not deformed in any way because of some strange wobbly refraction. In exactly the same way as it rotates in the north, it rotates in the south, but in the opposite direction.
Yeah, and I'm just pulling up that picture right now, and then I'll send it over to you.
Yeah, if you drop it in the general chat, I will post it up.
Okay. Pulling it up. Kind of a video for it. I'll try and take a...
We'll have a look at this, and then after
I'll
that,
get a video for you. I'll send a link to the video, and I'll also send you a picture.
Yeah, I can't play the video right now,
yeah,
Carl. If you've got a photo, I'll stick that up, and then I think what we'll do is we'll talk about that for a few minutes, and then, to be honest, I've been going for nearly 3 hours, so at that point, I think I'll bring the stream to an end. It has been really enjoyable. I can't see this picture yet.
I'm still trying to copy and paste it here. My computer's being a little slow. Oh, there it goes.
Well, it's in chat, is it?
Good try.
I can't see it yet.
Yeah, just being a little slow. Sorry. I'll just screen it. That'll be faster. Okay. And it's taking me a little bit here to get it to you.
Because those star trails in the south, just like in the north, will be following their perfect circles around the point of rotation. The further, they're making those circles. They're not distorted by. Oh, I'm getting feedback, Johnny.
I got you the picture. It's one picture. There's some better ones.
Oh, you dropped it straight to me. I can see the video, or at least it looks. Is that a video or is it a picture? Oh, it's a picture.
It's a picture.
Oh, I
of
see.
a video.
I see. Yeah. Okay. Yeah. Okay. Let me see if I can capture that one and then resize it to try and show it.
Okay.
Just bear with me a second. Because of course that's quite small in the middle. I should be able to grab that.
And
yeah, I've got it. Let me just resize as best I can. I'll maximize it as much as it will let me. So is that a glass or something? It's got circles drawn underneath, hasn't it? Okay. Right,
so, man,
it should be appearing on the screen in about 30 seconds. It's some sort of, what is it? A hemispherical lens, is it?
Yeah, it's a lens that you're looking through, and you can specifically see 2 points of rotation in this lens.
But can you
even though
not
there's
see
only
a big,
actually one?
Can you see a big, I mean, a massive problem with that?
Well, I can see that the lens right now in this shot that I sent you, it's not perfect. Not perfect circles.
No, no, it isn't.
In the sky here.
On the left, they start off pretty much good circles.
They're,
on the
they're
right,
different shapes. I can see
on the right, they're nothing like it. But even straight vertical between.
This is just me grabbing it.
Okay. But what I'm saying is, looking vertically in the middle from 6 o'clock to 12 o'clock. Those lines bend to the left, then bend to the right, and bend the other way, and so on. Whereas, in fact, if you're at the equator, looking at a star appearing due east, it will go in a perfect straight line, cross you 90 degrees above you, and set perfectly west. Absolutely straight line. No distortion whatsoever. This is, Kyle, I would have to say, this is distorted to buggery.
Oh, I agree. There's some better examples of it, and that was just kind of an error. But Harold, my screenshot thing is working better now. Let's see if I can send this one over to you.
Oh, you got another one. Okay, let's see if we can get this other one.
Upload. It's sending to you right now.
Okay.
Processing.
Right. Yes. Okay. That
one's much less distorted.
Yes, that's true. That's true. Let me. Oh, there it is. That's appeared now, I think. Actually, I'm just going to. Bear with me a second. Oh, it's picking up the wrong windows. This is where it gets confusing. Let me try and find it. Oh, why isn't it picking up that window?
Now, I believe this glass that we're looking through is the same kind of that hemispherical kind of glass that is used often to describe how seasons can be described on a flat Earth by shining it through some kind of a glass like structure right here. Yeah, so they've just flipped it upside down so you can see these different lines that are forming these things. And the actual things, this just looks like a whole bunch of lines, kind of like an onion cut in half. You see a whole bunch of lines, circular lines around each other. And even though there's only one point in the center there, it ends up, for some strange reason, looking like there's 2 points of circles. Does that make sense?
I'm not quite sure what you're saying. This is a much better image, obviously, of what you were trying to show. But they aren't circles. If you're stood there looking at one of those points of rotation, for want of a better word, you've got ovals, not circles.
And I'm not doing a very good job at describing the circles that I'm talking about, because the circles I'm talking about are only seen at like the very beginning of the video. And I sent you a link to the video so you can see a little bit better of what I'm describing.
This lens that we're looking at, that we can see the lines, is it a hemisphere?
Yeah, it's one of the. Okay. I told you it's the same kind of hemispherical lens.
So what we're looking at then is we're outside the dome, in effect, looking at lines on the flat Earth. Okay, now, if you were stood,
you're looking at it the wrong way. The thing we're looking at the bottom. We're looking at the flat side, looking up. So the curved side. Does that make sense?
The curved side. Okay, so the curved side is
the curved
on
side
the paper.
Is facing down.
Okay, well that's fair enough. Okay, because people are saying, and they're quite right, if it was the other way, then any distortion is totally wrong. The other thing I would say is that's a lump of glass. It's not even a dome or a hemisphere. Do you know what I mean? Half of a sphere, but hollowed out. That's solid glass.
Yes.
It's not really an equivalent to our atmosphere, I don't think.
I never said it was. I said that there's a big firmament over our head, and this is just one way it could be shaped. And now there could be a pocket that it is underneath it. And so we got to think about scale here. We're really, really teeny tiny. Think about how small we would be on the bottom of that glass. And so there's some space between us and the top of that glass where it starts. Does that make sense? And so our camera is actually quite far away from the bottom of that glass when we're looking through it. We're seeing those 2 points of those 2 circles. Our camera is quite far away from it. And so...
one thing that would be interesting, okay, is that camera is above the center of that lens, isn't it?
It is above the center of the lens.
Yeah,
yes.
it's looking.
So this would be.
It's looking.
So we're like pretty much standing
hold on.
on. Like,
it's looking straight down, but at the center. So if you move that camera a little to the left or to the right, still looking straight down, how would those distortions change? I'd be willing to bet it'd be more like that previous photo, and you'd no longer have 2 roughly equivalent halves.
That's a great observation, and I think that. This has been on my list of things I want to get so I can do my own examples with it because I think it's so cool. So that's one thing I would love to study more about because I don't have one of those kind of lenses right now, but it's definitely one I'd love to do. And it'd be very much worth a video to get an example of that.
Okay. Well, I mean, I think I'm going to wrap up now, guys. Do you know what? With the 2 of you, I have really, really enjoyed it because we've been able to discuss, argue without being... nobody has been nasty to anyone else, have they?
Yes,
absolutely.
Yeah, I think you're a good friend here and everything. I love being able to have these kind of conversations, and I think there's a lot to be learned from them. I always say, if you want to learn something, you've got to have something to contrast.
Yeah, well, I do want to thank you for coming, Kyle, because it was fairly short notice for you.
Hard to learn in an echo chamber. There we go. It's hard to learn in an echo chamber, and so it's really nice to be able to talk to you.
You're right, because no one's ever going to challenge you in the ways it needs challenging. So no, you're absolutely right there. And the same goes from our side as well. You know, we can always teach each other everything, but then we get asked questions that we've not thought of by you guys. So it's always good.
It's win-win. It is.
Yeah.
I mean, I hope, Kyle, that every now and then we can do this. And for me, the idea would be if you turn around one day and said, "Do you know what, Mr. S? I don't think it's a flat Earth anymore."
We'll see.
We'll see.
I'm really... We'll see.
So, yeah.
That's the fun part about doing my big mind mapping board is I can keep everything right there and
Well, I can understand that as a way of organising your thoughts, but I'll be honest as well, Kyle, I don't think I could sort of use that as a way of debating. You must have seen how people, when we were on our Discord yesterday or whenever it was, were getting frustrated because you were taking them through, do you agree this? Okay, next step, do you agree? And that was very frustrating for people rather than you...
That was because we were in a chat box, and the whole idea of the mind map is to get rid of the chat box. Chat boxes are really difficult. I just can't stand chat box debates because I can't address multiple people at the same time, and I can't address shotgun argumentation where they just launch a whole bunch of different points at you all at once and expect you to answer it all in a very teeny, crowded space. But with the whole mind mapping thing, you can branch out. You've got lots of elbow room, and shotgun argumentation isn't a problem there. And that's the beautiful thing I love about it.
Okay. Well, Kyle, what I want you to take away from this as a task is to have a look into meteor showers. Specifically, have a look at Perseids, which is the one I was talking about. That's Perseids. Okay, that'd be cool.
I
And
will
I'd
look
love
into
to.
that, and I will make sure to specifically put meteors and your whole argument that you presented here on my mind map, and so I can address that more fully in a public setting, and so everyone else can see it too. Nothing will get slid under the rug. Nothing has to be kind of lost in old conversations. It's all going to be there, so everyone can see it.
Well, yeah, because I use that as an argument. You made the comment about there could be several explanations, which I'll be interested to hear. Forget about the volcano thing. I'm not going to hold you to that. Maybe you'll come back and say, no, I do think it's the volcano thing. That's fine. But I'll look forward to whatever your responses are to that. I've just had a super chat from Bjorn Kamitz for 50 Swedish kroner saying, Mr. Sensible, these calm chats are very nice, in my opinion. No name calling, just trying to understand the other side. Thank you, Bjorn. That's what I think too. And yeah. Okay, so Johnny, I'll tell you what, Kyle joined at fairly short notice. You joined at impossibly short notice, about 5 minutes. I actually had the stream created and I'm sat here ready to go when I dropped him an email, but you're there. Brilliant. I really, really enjoyed it and enjoyed getting to know you.
Not a problem, not a problem. Well, cheers for having me on, and
Thanks for having me.
happy to chat anytime.
Yeah, well, you're both very, very welcome. And please join me again sometime, okay?
Absolutely. I'll definitely be back.
All righty. Well, okay. Thank you very much.
Mate.
Yeah. Good night, guys. Good night. So, everybody, thank you once again for joining me. Thanks for all the comments, getting involved, for the super chats, to my wonderful patrons and members. I appreciate you all. It's been a great evening, one that I had no plan for. And as usual, those are the ones that turn out to be the most interesting and I think probably the best ones. So I'm going to say thank you all for joining me tonight. Look forward to seeing you. Keep an eye out for an announcement with regard to Mage. Have a look at my Mage competition video. I've had a number of entries. Still plenty more heights to guess. You could win one of these. Let me just quickly grab one. One of these wonderful Mage patches. Roughly designed by me. My rough design fixed and turned into this beautiful... Oh, no, can't show it on the green screen. This beautiful image by Osvaldo Greco. One of these is going up in Mage, and you can win it. I look forward to seeing you all again soon. Until next time, stay sensible.